you will have a shared screen.
Yes, I
Screen
see.
share
Yes,
option.
yes, yes. Yes.
So if you click on that, it should be uploading.
Yes, I think it's on. Yes,
Yes, sir, we are able to see your screen, your PPT.
yes.
So yes, sir, you can run the presentation, sir. So once we are done with the introduction, then we'll just let you know so that you can share your screen, sir.
Okay.
Thank you, sir.
Thank you.
Thank you.
Just 1-2 minutes. Good morning, all. Good morning. Greetings and warm wishes to all the distinguished speaker, delegates, and participants joining us this morning for knowledge acquiring, sharing, and enhancing. This is a privilege and honor to welcome you all. I, T. Prasanna, Assistant Professor, ECE, Stanley College of Engineering and Technology for Women, welcome you all to the three-day uh, day three of keynote sessions in the first international conference on applied mathematics, modeling and simulation in engineering, AMSE 2021, organized by Stanley College of Engineering and Technology for Women in collaboration with IOP Science, Journal of Physics conference series. We welcome you all. It is a privilege to introduce our distinguished speaker, Professor Saifuddin Kadri sir. Welcome, sir. Sir is here.
Sir, Professor Karthik, can you please
Yeah.
switch on your video? Just
Yeah,
for a
thank
few
you.
minutes.
Yeah.
Welcome, sir. Professor Saifuddin Kadri has bachelor degree in 1999 from Lebanese University, MS degree in 2002 from Reims University, France, and EPFL, PhD in 2007 from Blaise Pascal University, France, HDRD in 2017 from Rome University. At present, his research focuses on data science, education using technology, system analytics, stochastic systems, and applied mathematics. He is an ABET program evaluator for computing, ABET program evaluator for engineering and technology. He is a full professor of data science at Norway University College, Norway. We welcome you, sir. And sir will be delivering the lecture on some new results on the product and ratio of random variables with applied applications. Welcome you all, sir.
Thank you.
Sir, now I request you to continue the session. Thank you.
Yes, thank you so much. I just need the permission to share my slides. So I'm still waiting the permission to share my slide.
Sure, sir. We will make you presenter. Just a minute, sir.
Okay.
Sir, permission is given, sir. You can start sharing the screen, sir.
So can you see my screen now?
Yes, sir.
Yes, sir. Yes.
Okay, so thank you so much for this kind invitation from the Stanley College of Engineering and Technology for Women. And I'm happy to be with you today to present this talk, which is titled Some New Result on the Product and Ratio of Random Variables with Applications. So as you see from the title, we're going to talk about the distribution, probability distribution of the product. Like for example, if we take two variables, x1 and times x2, where x1 and x2 follows two different distribution, probability distribution. Our aim is to find the probability distribution of their product and for the ratio. In addition to that, I will present at the end some real-life applications where we can use our result. Okay, so this is the plan for the presentation. So first, I'm going to start with the literature review with some brief summary of what's happening in this domain. Then after that, I'm moving to the some new result where we use a well-known methodology to find the probability distribution function of the product of three variables. In section 3, I'm going to present the product and ratio. Actually, it's a new distribution, so this is our main result in this section. Also in section 4, some of our result, a new result recently developed, which is the distribution of product of n independent Maxwell random variables. Section 5, some real-life applications, and then conclusion and references. So as you can see, the topic of the talk is related to the probability distribution. And we always interested to find the probability distribution of the product and quotient of random variables, because we found many applications in engineering, in economy, in different fields of sciences require the distribution of the product and the ratio or the quotient of random variables. Of course, we can use anytime some approximation method or some simulation method like Monte Carlo to find the PDF, the probability density function. But our aim in this talk is to find the probability density function, but in analytical form or closed form. So we will get it like exactly and not approximately or using a simulation. So in this part, just briefly, I'm going to take three different results exist in the literature. Of course, we can find many results, but just to take this three different results. So in the literature, we can find the probability distribution function of the product and ratio of Maxwell and Rice random variables. So basically here we're going to see that we have X, a random variable follows Maxwell distribution, and Y is a random variable follow Rice distribution. Then in this result, in this existing result, we can see the distribution of their product. We're going to see after the distribution of the ratio of exponential and Rayleigh random variables. So we're going to have like X follows an exponential variable and Y follow a Rayleigh random variable. Then we're going to see the existing result of the PDF of the ratio. Another also result existing in the literature is the product and ratio of Weibull and Lindley. So we're going to see, different kind of existing result in the literature. Here, for example, we can see that, for example, the distribution of Maxwell, it's a well-known distribution. So where we can say that X follow a Maxwell distribution if X if the distribution, function distribution of x follow this equation. So as you can see here, of course, x is the random variable and a is the parameter. So basically, a is the can differentiate between different Maxwell random variables. For the Rice random variable, we can see this is the distribution of the y, where y follows a Rice distribution. Of course, this is existing from long time. So in this function, you can see that the variable y is defined using two parameters, sigma and mu or v. So this is the result, the PDF of the z, the multiplication of x times y. So you can see here is the this is the PDF of the multiplication of x times y. Of course, this kind of result, we can say that it's a analytical form, okay, but also it's not very useful in real life applications, because here, as you see, we have an infinite summation or infinite series, which is somehow not practical when we try to implement this function, okay. But usually in this field, many times we obtain the PDF with like infinite series or like having improper integral. So this is the result of the x times y. So here you can see, for example, the result of the PDF of the ratio of x divided by y. So this is the analytical form of the distribution of the ratio. So as you can notice that also it's a summation, infinite summation. And also here we have the gamma function as well. Another existing result in the literature, we can see that we can take, for example, the distribution of x over y, the ratio, where x follow an exponential distribution and y follow Rayleigh distribution. This is a well-known, the PDF of the exponential, which is defined using the parameter lambda. And you have the Rayleigh distribution, which is defined using the parameter mu. Now, the probability density function of their quotient, you can see it in this one. Okay, so this is the analytical form, and also, as you see here, we have the error function of the R, or the R function, which also, I mean, we face some problems when we try to implement this function in Mathematica or in MATLAB. Another distribution existing in the literature, for example, the product and ratio of Weibull and Lindley random variable. So as you can see here, this is the PDF of the Weibull distribution defined by this function. And the Weibull distribution has two parameters, A and B. This is the Lindley distribution, and which has only one parameter, which is C. And you can see here the probability density function of their product, x times y. So as you see here, it's okay, it's analytical form, we can say that, but also it's not, it's somehow a little bit complicated when we move to the practice, because we have the infinite summation and you have also the gamma function. Here also in the same reference, in the literature, you can find the probability ratio, or the quotient, x divided by y. So this is the PDF. This is the analytical form. You can see also in the result, we have the xi function, which is the confluent hypergeometric function. Okay, so let's define our problem and the objective and see the result that we obtained. So in our study, Can you still see my screen?
No, sir. We have lost the screen, sir. Just can you share it again, sir?
Okay, so I'm not sure why I don't have the.
Presentation. Sir, I will give it
Yeah,
a
I find it. Yeah, it appears now. Yeah.
Thank
Okay, so this is our problem statement now. So in our study, we're going to focus on finding the analytical probability density function and some related statistical functions such as the cumulative, the moment, the expected value and the variance and survival function, hazard function of the product and ratio of some independent random variables from different distribution functions families. And as you know, once we got we obtained the probability density function, we can derive actually all other statistical functions easily from it. So the goal is to find the probability density function analytically of the product and ratio. And to the best of our knowledge, we didn't find in the literature the below distribution, which lead us to the following objective. So you can see here some of the objective of our study. For example, to find the analytically the probability density function of the product of three variables, x times y times u, when x is Pareto, y is Rayleigh, and u is an exponential. So we developed this result, which is not exist in the literature. We also developed the result of we find the PDF of the product x times y and x over y when x is follow Pareto and y follow exponential random variance. Also, we're gonna find the product and ratio for x and y when x is Pareto and y is Rayleigh. We found also the distribution where x is Pareto and y is Maxwell, x is Pareto and y is Erlang. Where when y is Pareto and y is hyper exponential, when x is Pareto and y is beta, x is Pareto and y is power function, and where x is Pareto and y is Weibull function. Then the last result that we got very recently is the probability distribution function of the product of n independent Maxwell random variables. So let's see the result. Okay, this is our first result. So in this result, we're gonna find the probability density function of the product of three random variables, x times y times u, when x is Pareto, y is Rayleigh, and u is an exponential random variable. Okay, so as you know that this is the Pareto distribution. This is the definition actually of Pareto distribution, where we have only we have two parameters, A and C. We have the Rayleigh distribution, which has the only one parameter, which is B. And we have the exponential distribution, which has only one parameter, is lambda. Now the question is how to find the probability density function of x times y times u. So we use the transformation method with some modification to it in order to find the probability density function of x times y times u, and also we use the Jacobian. So we obtain this function where r equals x times y times u. Okay, so this is an analytical form. It's clear that it's analytical form. The good things that we don't have infinite series, but we have also the gamma function. This is an example of numerical example of what we obtain. So this is, for example, for a equals 1, c equals 2, b equals 1, and lambda equals 1. And this is the graph of the of f of r. Of course, you can find easily the you can check easily the integral under the curve, which is equals to 1. So this is the PDF of the product of the three variables. Let's move now to another result where we will find the product of the ratio and the product and ratio of different independent random variables. And as you notice that in our study, we just take the continuous random variables. So we are not studying the discrete random variables. Okay, so let's start first where one of the variable is Pareto and other variable is exponential. So this is the Pareto distribution. So we're going to use this one a lot, which has only the two parameters C and A, and we have the Y is follow exponential distribution. So we developed like two different techniques or theorem to find the PDF. So as you see here, this is the PDF, and it's analytical form, and there is no like integral, improper integral, or infinite series. We just have the sigma, which is fine, the sigma function. This is a numerical example of the distribution of the probability density function of the product x times y, and this is the function using this numerical example. This is also the probability of the ratio of x divided by y. So this is basically the three branches of the function. Also, as you see, we have the we obtained in analytical form. It's somehow it's more complicated than the product. So we have here the function e, which is the exponential integral, and we have the sigma function. This is also the probability distribution function of the ratio of x divided by y, and this is the form of the function where we can find the numerical values. Okay, another result when the x follows the ratio, when the x follow the Pareto distribution and y follow the Rayleigh random variable. So this is the Pareto, we talked about it in the previous slide, and this is the distribution of Rayleigh. So it has only one parameter b. So using our developed techniques, we obtain the probability of the product x times y. So this is the PDF. It's analytic and it has the sigma function. You can see here the distribution of the PDF of the product, and here the function using this numerical values. Okay, so you can see here the probability density function of the quotient. This is the function. This is the analytical function when you have only sigma function in it, and this is the distribution of the quotient using these numerical values. Another result where x is Pareto and y follow the Maxwell random variables. So again, this is the Pareto distribution, and this is the Maxwell, where you can see we have only one parameter b, and this is the form of it. So we obtain the probability of the product x times y. So this is the analytical form, and we have only the sigma inside it. This is the numerical example with some numerical values, and this is the figure of the PDF. We can see here also the probability distribution function of the quotient of x and y, of x divided by y. As you see, where x is the Pareto and y is Maxwell. Here you can see the some numerical values for the parameters a, c, and b. And this is the graph of the figure of the PDF of the quotient. Another result also here when x follow Pareto and y follow beta random variables. So this is the Pareto, as you know, and this is the beta, where you have like two parameters, the v and w. Also here we obtain the analytical form of the product x times y, As you see here, this is the distribution, and you have here the numerical example of the PDF of their product. You have here also we obtain the PDF of the quotient of x divided by y, and this is the PDF of their quotient. Some numerical example where we take a equals 1 and c equals 2. This is the parameter of Pareto, and v equals 3, w equals 1, the parameters of beta. Then we got the PDF having this form. Another result also when we x follows Pareto distribution, and y follows Erlang distribution. So this is again the Pareto distribution, and this is the Erlang distribution. As you see, Erlang distribution has two parameters, lambda and alpha. So again, we developed the product of x times y, and we got the PDF of their product. So you can see here we have in the analytical form, we have sigma, the sigma function. So here we took the example, we took the parameters a equals 1, c equals 2, alpha lambda equals 1, and alpha equal 3. Then we got the PDF of their product with the figure of the function. This is the distribution of x divided by y, where x follows Pareto distribution and y follows Erlang distribution, and we got this PDF. Also, with the same numerical example, you can see that the function, the f function of the x divided by y. Another result where x follows Pareto and y follow Weibull random variable. So this is the Pareto distribution, and this is the Weibull distribution. And as you can see, the Weibull distribution it has two parameters, mu and beta. So this is the result that we got, the PDF of the product, the multiplication of x times y. As you can see here, we have the function sigma in the analytical form. And this is the numerical example, where a equals 1, c equals 2, mu equals 2, and beta equals to 1. This is the form, and this is the shape of the function. The result that we also got for the quotient x divided by y. So this is the function that we got. It's somehow a little bit complicated, but okay. So this is the an example, numerical example of it, and this is the PDF figure of the quotient. Another result where x follow Pareto and y follow the hyper exponential random variable. So this is the definition of Pareto, and this is the definition of the hyper exponential. As you see, the hyper exponential is a summation of exponential random variables. So we call it hyper exponential. And as you see, you can see that we have the two parameters. We have the p and lambda. But it's a summation of random variables, so we call it hyper exponential distribution. Now, we also developed the PDF of the product of x times y, and this is the PDF. And as you see here, we have a summation because the hyper exponential. But the good thing is that in this summation, we have a finite summation, not infinite summation. So it's summation from 1 to k. And you have also the sigma function. So this is the analytical form of the product of x times y, where x follow Pareto and y follow exponential. And this is the numerical example with some numerical values for the parameters. Okay, so this is the form, and this is the shape of the PDF of the product. Again, for the quotient of x divided by y, where x follow Pareto and y follow the hyper exponential. So we get this form for the quotient, and this is the numerical values with the with the form of the function and the figure of it. Another result where x follow Pareto distribution and y follow the power function random variables. So this is the function of Pareto, and this is the function of the power random variable. So as you see here, we have two parameters. We have alpha and beta, and this is the condition of on alpha and beta. So we got also the PDF of their product, x times y. So this is the analytical form of x times y, and this is the numerical example with a equals 1, c equals 2, alpha equals half, and beta equals to 1. Here also we got the PDF of their ratio, x divided by y, where x follow Pareto distribution and y follow power function. So this is the function that we got, the analytical form, and this is the numerical example. So you can find the values for the parameter and the form and the shape of the PDF of x divided by y. Okay, so the last result that we got is the distribution of the product of n independent Maxwell random variables. So as you can see from the previous result that we developed, we just take the multiplication or the product and ratio of two random variables. So the challenge there is to find, for example, the multiplication of n random variables, not only two, like x times y or x1 times x2 times xn. So this was a challenge. So that's why in the previous result that I showed to you, we just took two random variables and we developed the PDF of their product and of the ratio. Now for this result, we go like one step further and we develop the product of n independent Maxwell random variables. So as you know, this is the distribution of Maxwell. So we have one parameter beta, and the goal is to find analytically the probability distribution of the product. So we need to find the PDF of xi, the product of xi, when xi is a Maxwell random variable. So for this one, we use different kind of special functions. So we use the Mellin integral transformation, and also we use the this is in fact the Mellin transformation, and we use also another type of special function, which is the major G function. Okay, and so and we developed the PDF of the multiplication of n random Maxwell random variables. So this is actually the form of f of x. So you can see the multiplication, and you have here the G function. And this is a numerical example. So we take, for example, like 10 random variables follow Maxwell distribution. And we took these values for the parameters, because as I said, the Maxwell distribution has one parameter, right? So which is b. So that's why in the numerical example you can see that we took like b equal 1, b1 equals 1. So this is the parameter of the first of x1 of the first Maxwell random variable. This is b1 for the second one, for the third one, and so on. So the probability density function of the product given by this function, and this is the shape of the function. Okay, so after we saw the somehow the new result, Let's see the some, I mean, real application, or just to see the benefit of our result using an applications. Okay, so the first application, we're gonna use the product of the n independent Maxwell random. So basically, it's just the last result that I just presented to you. So we're gonna apply the result on something called the Maxwell-Boltzmann distribution. Let's just see the context of this one. Then after we see how to apply our result. So the air molecules surrounding us are not all traveling at the same speed, as all we know, even if the air is all at a single temperature. Some of the air molecules will be moving extremely fast, some will be moving with moderate speeds, and some of the air molecule will hardly be moving at all. Because of this, we cannot ask a question like, what is the speed of an air molecule in a gas? Since a molecule in a gas could have any one of a huge number of possible speeds. So instead of asking about any one particular gas molecule speed, we ask the question like, what is the distribution of speeds in a gas at a certain temperature? James Clerk Maxwell, the one who discovered the Maxwell distribution, and Ludwig Boltzmann figured out the answer of this question. The result is referred to as Maxwell-Boltzmann distribution because it shows how the speed of molecules are distributed for an ideal gas. So this is basically the distribution of the Maxwell-Boltzmann distribution, and here you can see some explanation of the axis. You can see here the x-axis is the speed, and the y-axis the number of molecules per unit speed. Now let's see how to apply our result and take the following example. So we are interested to find the distribution of x equals x1 times x2, where xi, x1 or x2 are independent Maxwell random variables with a scale parameter bi, which b1 equals 1 and b2 equals 2. Now the speeds of the molecules are distributed for an ideal gas with respect to the probability density function of x. Now here we use our result to find the probability function of x, so we can see the speed of x1 times x2. So our result give this distribution function of the product, and you can see here the numerical values, and you can see so our result is in blue. This is the analytical form. And also what we did, we used the Monte Carlo just to confirm and to verify our result. So as you see here, in blue, the blue curve is the analytical function that we obtained using our result. And the orange bars is the Monte Carlo simulation. So I believe here we did like 10,000 simulation. So as you can see that the Monte Carlo simulation confirm our analytical result. Of course, Monte Carlo simulation is an approximation, but sometimes we use it to verify our result, and other times we use it if we cannot find the probability distribution function in analytical form. In that case, we use Monte Carlo simulation instead. Okay, let's see another type of application where we use the product of Pareto and Rayleigh random variables. Okay, let's see this application. So the Pareto distribution was named after the Italian economist. So it was an economist, Pareto, and sociologist Vilfredo Pareto. It's sometimes referred to as Pareto principle or the 80-20 rule. The Pareto distributions serves to show that the level of inputs and output is not always equal. The Pareto probability distribution is widely applied in different fields such as finance, physics, hydrology, geology, and astronomy. Engineering, for example, Pareto distribution describes the extent loads on wind turbines. Okay, let's see the application. The Rayleigh distribution is employed in the field of nutrition, for example, for linking dietary nutrient level and the human and animal responses. Also in magnetic resonance imaging, MRI. So MRI are recorded as complex image, but most often viewed as magnitude images. The background data is Rayleigh distributed. In addition, the Rayleigh distribution is widely used in the electric field. For example, Rayleigh probability distribution function was used in order to estimate the mean wind speed and calculate the annual energy output from a windmill at the understudied location. So suppose that we have a wind turbine. Let X1 describe the extreme loads on the wind turbine that follow Pareto distribution with parameter C equals 1 and A equals 1. This is the Pareto distribution parameters. And let X2 describe the wind speed, which follow Rayleigh distribution with parameter B equals 1. Then Z equals X1 times X2. So the multiplication of these two variables now, when X follow Pareto distribution and when X1 follow Pareto distribution and X2 follow Rayleigh distribution, the multiplication now can estimate the energy output from a windmill at the understudied location. And by using our result, we got the PDF in analytical form of their multiplication. So you can see here.
Actually, we have lost your presentation, sir. Professor Khatri, we have lost your presentation.
Sorry.
Can I just reshare, sir?
Yes.
Thank you. Sorry to interrupt.
No, it's okay. I don't know why sometimes it. Yeah. So in the second application, as I mentioned, the purpose was to find the PDF of X1 times X2, and as you can see here, X1 follow the Pareto distribution, and X1 represent the extreme loads on the wind turbine, and X2 is another random variable which is follow the Rayleigh distribution. And X2 describe the wind speed with parameters B equals 1. Now, by using our result, we can find the probability density function of X1 times X2. And in this case, the multiplication of these two random variables represent or can estimate the energy output from a windmill at the understudied location. And by using our result, we can find the PDF of their multiplication, which is having this form. So here you can see the after we got these numerical values, we draw the PDF function of the multiplication of X1 times X2. And again, X1 follow Pareto distribution with parameters A and C. And X2 follow the Rayleigh distribution with parameters B equals 1. So as you see here, we also use Monte Carlo simulation to verify our result. So the blue one, the blue curve, is the analytical function representing this one. And the orange bars, as you see here, the histogram represent the Monte Carlo simulation. And you can see that our result is confirmed using the Monte Carlo simulation. So in the conclusion, in the conclusion of this study, so determining distribution of the functions of random variables is a very crucial task, and this problem has been attracted several researchers because there are numerous applications in different field of science, like for example in risk management, in finance, economy, engineering, and many others area. So our work is trying to show the analytical probability density function of some distribution for mathematical operations like the product and the ratio. And our focus was on the, as I said, on the product and ratio. So this is the summary of the different sections. And you can find here some references in addition to the output. So this is basically the presentation. So we can move now to the questions if you have any questions on that.
Thank you, sir. Thank you for your presentation
Thank you.
and very good insight about the probability distribution functions. I would like to summarize your lecture, sir. Probabilities of occurrence of different possible outcomes in any experimental analysis can be studied from mathematical functions known as probability distribution function. Professor Katre introduced various key probability density functions of product rates of random variables. To begin with, he introduced the mathematical functions of Maxwell and Rice distributions. He illustrated the distributions like Weibull and other distributions as Maxwell-Boltzmann distributions. Sir, you mentioned about the Pareto and Rayleigh exponential distributions and their relevances in statistical studies. Sir, you explained the Monte Carlo distribution with regard to independent maximum variables. Sir, you shared outcomes of rigorous research on pioneering area of random variable analysis. This will certainly benefit to the budding researchers pursuing their research work in the School of Statistics and Probability. I have a personal doubt here. Sir, can we use these distributions for analyzing COVID-19 data, like any medical data like this?
Yes. So the question is, can we use this distribution in helping understanding the COVID-19? Right. This is the question.
Yes, sir. Yes, sir. Yes, sir.
Yeah. So this is a very good question, and of course, using the probability distribution, we try to understand how for example, how the speed of or the growth rate of the COVID-19. So this is basically can be modeled using the probability distribution, and can, for example, like using some data, we can find the distribution of the speed. Like, for example, if we discover, for example, the coronavirus in China, and using some data, what is the speed and the growth rate to reach, for example, India. So this is, of course, can be modeled using the probability distributions. Yes.
Okay, sir. Thank you very much for the answer. And one more question, sir. How can we use this to the communication field, sir? These distributions.
Yes. Yeah.
So you have given the example of windmill.
Yeah. Yeah. So this is also an interesting question and study. I didn't mention here the application in the communication, but we have one application because, as we know, that the communication is based on signal and based on Shannon theory, and this is also based on the probability distribution, because by using the probability distribution we can calculate, for example, how far the signal what is the probability that the signal in the communication can reach this kind of distance, right? So we can find a very good application. I haven't mentioned here, but if someone interesting, I can send you the application that we developed in the field of communication.
Okay, sir. Sure, sir. We will keep in touch with email, sir. We will post. Thank you. Thank you, sir. Thank you very much. Any other questions from participants? Sir, participants will be posting questions in YouTube channel, sir. We will forward those questions to your email.
Yes.
Please find time to answer them, sir. Thank you.
Yes, sure. Thank you so much.
Sir, we would like to invite you for our international conference, sir, on 15th and 16th. Please join us, sir. And
Yes.
one more thing is, we will send you the appreciation letter through email, sir, to you. Thank
Yes,
you.
thank you so
Thank you,
much.
sir.
Thank you so much.
Thank you, sir. Thank you very much for joining with us. Thank you.
Thank you.
Thank you, Professor Kadri. It was a pleasure to hear you, and thank you for enlightening all the researchers. I'm sure many of the researchers got a glimpse of what areas they can work. Thank you very much, sir. And
Thank
we'll
you so
stay in
much.
touch with you for any other collaborative work. And definitely, we would like to have you in the events that we conduct in future, sir. And
Yes.
please do continue to stay with us for the other sessions if it is possible.
Yes, thank you so much. I will. Thank you so much.
Thank you, sir. Thank you, sir. I now request Prasanna to please continue the session. We have Dr. Sarvanan already in the group. Welcome, Dr. Sarvanan. So, am I audible?
Yes. Good morning, ma'am. Can you hear me?
Yes, yes, sir. Yes, sir. Yes, yes, sir. Welcome to the stage, sir.
Yes.
So we'll just start in about 5 minutes. Another 5 minutes, sir.
Yeah, sure, ma'am. Sure.
Just check out. I have had YouTube links with that group, and we just check them out, and then we'll join you, sir.
Sure, ma'am.
Sir. Okay. Thank you. Thank you.
Thank you.
Dear participants and delegates, the next session will be with Dr. K. Sarvanan, sir. He will be delivering the lecture on secure, sustainable smart cities and IoT. To start the session,
Good morning, Dr. Sarvanan. Dr. Sarvanan, I request you to switch on the video if you are comfortable with it. Am I audible? Dr. Sarvanan? Good morning, sir. We are able to see you, sir. Thank you. Good morning to one and all, and I welcome Dr. Sarvanan to the session. I request Mrs. T. Prasanna to please introduce the esteemed speaker to the audience. Thank you.
Once again, good morning to all. Good morning, sir. I am T. Prasanna, Assistant Professor, EC, Stanley College of Engineering and Technology. Would like to introduce you. Dr. K. Sarvanan is working as a Senior Assistant Professor, Department of Computer Science and Engineering at Anna University, Regional Campus, Tirunelveli, Tamil Nadu. He has done ME Software Engineering and PhD in Computer Science and Science Engineering. His research interest includes cloud computing, software engineering, Internet of Things, smart cities. He has published papers in 14 international conferences and 27 international journals. He has also written 14 book chapters and edited 7 books with international publishers. He has done consultancy work for municipal corporation and smart city schemes. He is an active researcher and academician. Also, he is a reviewer of many reputed journals in elsewhere, IEEE, etc. He is a member of ISTE, IEI, ISCA, ACM, etc. He had also interviewed engineering college students for placement and training and counseling. He has conducted many ISTE workshops in association with IIT Bombay and IIT Kharagpur. Also, he conducted NPTEL workshop for the faculty and students. He is also coordinator for IIRS, Indian Institute of Remote Sensing outreach program. He has delivered more than 50 guest lectures in many seminars and conferences in reputed engineering colleges. Welcome you, sir. And sir will be delivering the lecture on secure, sustainable smart cities and IoT. Sir, it is very pleasure to have with us, sir. Thank you. Thank you very much. And I hand over mic to the sir for next session. Thank you.
Yes, thank you, ma'am. Thanks for the nice introductions. And I appreciate the organizers for neatly organizing the entire, there is a conference program. Right, so this is about secure, sustainable smart cities and IoT. So this is there is a presentation today. So we can straightly move on to the various slides.
Just a second, sir. I'm uploading your presentation, sir.
Yes, sure. So this slides is about there is a smart cities as well as IoT, right? How we can use the IoT environment, IoT technologies, right, in development of the research smart cities?
It's uploading, sir. It's converting to and upload.
Okay.
Thank you for the patience, sir.
Yes, ma'am.
Yes, sir. We are on, sir.
Yes, right. It says the title says it is secure, sustainable smart cities, and so devotee, right? Any smart city, right? It is the goal of the smart city is to improve the quality of the citizens, right? And it should be a sustainable manner and how secure, right? When we use there is an IoT, right? So it should be highly there is a secure environment also, right? That is going to be the session today. So next slide, please. So what does this mean by there is a smart city? Right? Actually, there is no direct definitions, right, when it comes to there is a smart city environment. So there may be some IEEE definitions, but it depends on the city to city environment as well as to this country because there are some developed cities and also there may be a different cultures, different environment, right? So there is a different needs for the peoples also, right? So the smart city different definitions, right? It's not very common actually, right? So due to growing this organization, the smart cities are inevitable in today's technology world, right? Even we say there's more than half of the human populations, around there is 60 to 70 percentage of human populations are now living in the city environment, right? So the smart cities market size is estimated to US dollar 2.57 trillion. So by the year of there is in 2025, it is expected, and also right the more number of smart cities to join, right, and also right is going to develop, right. The predicted the market size may it is increase a lot. So the goal of our smart cities, right, is to provide a safer as well as the better quality of life to the citizens, right, living in the smart cities environment with a reduced economic cost as well, right, and also more there is a comfort, right, with the help of this IoT engine. So next slide. You can see that there is a urbanization rate from the 1950 to the 2015, about there is in 100 years. You can say that from 29.6, right, there is at the rate of now it is going to be 68.4, which means so around 70 percentage of the world populations will be going to live in the city environment only, right? So that's why, right, you have to develop, right, the city environment. There is a more smarter, right, more smarter because there is a more number of there is a people going to employ. Right? They will have to transit, right? There is more kind of there is employment opportunities, right? So we have to make it there is a more comfortable, right? There is a zone to the kind of citizens. So next slide. Yes, next slide, please. Yes. So when you say that there is Internet of Things, when you compare with there is a populations, right, with the kind of there is an IoT devices. So we have, right, what is in, you know, right, what is meant by IoT, right, Internet of Things. So any device, it could be a sensor, it could be a mobile device, it could be a laptop, or it could be an actuator, right? Something that could be able to that is connected with an internet, right, which is we can call as an Internet of Things, IoT device. So the IoT device that will be installed and it is growing year by year. So in the year 2015, the connected devices in billion, you could say there is 15.41, but later in 10 years, in the year 2025, we say that it is a 75.14, right? 75.14 billion number of devices is going to be connected, right? Which means more number of devices, right, going to be connected in a there is a smart city environment also, right? You will be able to access the services by using this IoT environment. So next slide. So the attractive opportunities in the smart city that is in market, there is a 410.8 US dollar in the year 2020, whereas it is going to be expected, right, it is in the year 2025, 820.7 US dollar billion. So So the annual growth rate also will be getting increasing, right? It is in 14.8% of annual growth rate when compared to in IoT devices. So when we say that, right, that the growth rate is increasing, the billion number of devices is going to be connected, the smart city market size will be going, right? So what is the right the advantage when it comes to research and innovations, right? So there is a more number of services, more number of applications. So more kind of there is a research is needed, right, in the kind of the smart city environment, right? So because smart city will have a vertical in all the domains, like in healthcare, educations, there is an e-governance market, solid waste management. So probably in a waste water distributions environment, right? And then smart street lights environment. Then we have when come to surveillance, CCTV surveillance, security schemes, smart parking schemes, and then smart traffic management, and also more kind of there is citizen portal services and geo-tagging of all those kind of there is locations. So there are right, we can say that n number of there is an applications has to be developed and should be integrated, right, and should be integrated into the smart city environment, right? So with the help of right the IoT as well as we have the 5G and then 6G mobile communication technologies now is going to evolve, right? That will help in the smart city environment to grow a better way. So there is called the factors such as the need for public safety and communications infrastructures and increase the adoption rate of advanced technologies are driving the smart city market, right? So we have the advanced technologies like IoT and then big data, cloud computing, edge computing, fog computing, technologies will act and then give us a training that is enforced for the smart city development. So next slide, please. So the evolution of there is a smart city. When you start developing the smart city, right, it's not like a straightforward just a combination of this IoT technologies and then putting this devices and all, right? So it's about to have the four stages. First stage is about the early stage, right? Because the smart city definition differ from city to city, right? So you have to arrive the smart city strategy, right? So what is mean by the smart city strategy? So whether we have to right entirely going to develop the smart city environment or we are going to redevelop the particular environment, right? Whether it is going to the particular area or to the entire there is a pan city environment, right? So which vertical we are going to concentrate. So we have to arrive a strategy for our right for smart city environment. It differs from city to there is a city, right? And definition of the cities and then cities cities an indicator, right? Because every city you have there is unique cultures, unique there is an unique environment, right? Pattern, right? So depends on that, right? We have to arrive the decision and priority in verticals to optimize, right? There are different verticals in smart city environment. As I said, we have the healthcare, we have the education environment, right? We have the logistics, we have the retail, right? We have the e-governance environment, right? So there are many verticals available, right? So we have to choose, right, which vertical we have to concentrate. So it also depends on the city to city environment. So that's why, right, when it comes to the development of the smart city environment in India, especially, right? So each there is a city chooses a different there is in verticals and develop those solutions for. Okay, so for example, so for a city, right, it is going to be there is a smart water distribution is important, right? They have to employ a system like there is in SCADA, right, for that. And another city maybe implying there is a smart street light as well as CCTV surveillance in which the security, right, and the surveillance is less, right? So depends on the right the need of the citizens and the need of the city as well as to the culture, right? We can employ the different that is vertical as well as different solutions. So once we identify the different verticals, right, the next solutions will be right. So incorporation of IoT technology, right? For example, right, if you identify a solid waste management, right? So and also for an environmental, right? So you have to employ those kind of IoT sensors, actuators, right, as well as the devices in it, right? So once we identify the particular domain, so we can employ the corresponding there is a sensor in it. Right. So, for example, here in there is a Tirunelveli Municipal Corporation, which is located in the south part of there is in India, right, where and there is a residing. So, they have employed right the SCADA system for our smart water distribution systems. So, it has both quantity as well as the quality sector because it has a right. There is a fortunate it has a there is a Tamarabarani, there is a river, right? So we want to quantify the right the river distribution. There is a river water distributions across the cities. So they are employing there is energy sensors and as well as a quantity what we call the pressure sensor right, as well as the flow transmitters, right, as well as there is pH. When it comes to quality sensors, they have a pH sensor, they have the chlorine sensors, right, turbidity sensors. So depends upon there is in vertical, depends upon the need, right? They would employ right, smart water distribution, solid waste management, right, as well as a smart parking and CCTV surveillance, etc. So the second stage is about right identifying the verticals. The third stage, right, it is there is one very important, right? So after right we have developed the solutions in each vertical, right? We have to connect so all those kind of there is a vertical right into the there is a unique way something like an right integrated there is a platform, right? So that's where in India, right, we have something like an integrated command control center, which you can call it as an IEEC there is a platform. So what this IEEC platform does is right, it has to connect so all the individual there is a vertical platform, right, and it will consolidate all those kind of data, right, to an other in single manner, right. So for example, right, so there is a commissioner of the municipal corporation authorities can straight away right, walk through this IEEC room and they can see there is a real time data of maybe the COVID-19, there is a data actually, right, and where the traffic lies on the particular traffic. So what is the death rate or what is the birth rate on the particular day or a month or a week, right? So and also what is how many the street lights are not burning, right? Which are in now repair conditions? How many grievances are there is already addressed and how many of them been taken? So all this kind of there is an information right accumulated and shared in this attribution platform that we can do there is a more kind of there is an analytics skill, right? Because once we have this kind of consolidated data, right, in that attribution platform, integrated there is a domain platform, so we can do that there is an analytics with the help of there is a big data or a machine learning, right? So with those kind of there is in technologies, right? So the third there is in solutions is about the connected there is a platform, and fourth one, right, is about there is an engine of growth. So we have more kind of there is an optimization of this kind of there is a platform, right? You have to optimize right the smart city environment, make it in a sustainable there is a city, right? So that is going to be the engine of there is a growth. So there is an evolution of the smart city. And the local government is the owner of the data that the city generates. So the local corporation authorities, right, they're going to govern this data, right? They are the authorities, right? They're going to monitor and control this environment and also the smart city there is a data as well. Next slide, please. So,
You want us to run the video?
Yes. This video will give some sort of illustrations of how the smart city works.
Just how smart is your city? Chances are it's getting...
So shall I play?
Yes, ma'am.
Smarter by the year. Many governments around the globe are racing to infuse technology into just about every aspect of its city's operations. And I mean every part, including public transportation, IT connectivity, water supply, sanitation and solid waste management, efficient urban mobility, e-governance, and citizen participation. And it does this using every buzzword imaginable, from big data to the Internet of Things. So how does a smart city work? Let's look at 3 examples. Here in Singapore, the city-state might be the gold standard of the most extensive effort to collect data on daily living. The government is now deploying systems that can tell when people are smoking in prohibited zones or littering from high-rise housing. Singapore launched its own Smart Nation program in 2014 and will add more cameras like these so the government can effectively monitor crowd density, cleanliness of public spaces, and even the exact movement of every locally registered vehicle. Much of the data it's collecting will be fed into an online platform called Virtual Singapore that gives the government access to how the city is functioning in real time. It could help the government predict how crowds might react to an explosion in a shopping mall, or how infectious disease might spread. Over in Dubai, more than 50 smart services from 22 government entities have been rolled out as part of the government's Smart Dubai initiative. Using the government-provided app Dubai Now, you can do things like pay a speeding ticket, which likely captured you on a public camera and then emailed you the ticket directly. You can also use the the same app to pay your electric bill, call a taxi, track a package you sent to your friend, find the nearest ATM, renew your vehicle registration, track the visa status of a relative, and report a violation to the Dubai police. Now, head over to Barcelona, where one research firm estimates the city will save billions of dollars a year in energy costs just by installing smart systems like these. Number one, smart streetlights. Public lighting that adapts to dim when there's no activity but brightens up when sensors detect motion. The second, parking sensors. Instead of driving in circles looking for a spot to park, drivers can get real-time information on an app which locates free parking spots. Sensors on the street curb use lighting and metal detectors to know if a parking spot or loading area is occupied. And finally, garbage sensors, which are actually compact drop-off containers which have a vacuum network through pipes which sucks up trash below ground. The automated waste collection not only lowers noise pollution from garbage trucks, but also lowers costs and keeps bad odor away. Juniper Research estimates that by 2021, cities will save nearly $19 billion by making their cities smart.
But of course, to save money, sometimes you have to spend it first. The global smart city market is estimated to attract $15 billion by 2021, and that's just for software. Now, companies from Microsoft to Cisco are aiming for a piece of it. In Singapore, Upton Saidi, CNBC.
Still watching? Perfect. Click here to watch another great video.
Yes. Yes, this is about the development of there is a smart city in Barcelona, there is Singapore, and many more. There is a smart cities in India also, right? We would expect these kind of the smart city environment because it's employing there is an IoT sensors, right? That will provide the huge potentials in the smart city environment. Next slide, please. So when it comes to the smart cities in India, right, we have a vision, smart city missions, and it says that 100 smart city mission is initiated with a US $15 million to make sustainable and citizen-friendly cities in a cost-effective way. Right? So these all 100 smart cities are already identified, and then so you would see that most of the smart cities, there is a developing the smart city solutions. But unfortunately, there may be minimal, there is an IoT based, there is a solution is involved. Some of them are based on there is civil works. But we have to probably in the future, so we have to employ more kind of there is an IoT solutions, right, to make it as a connected there is a city. Because when it comes to there is a smart city, it has to be make a more secure and then connected city. So with the help of there is an IWC platform only, it could be possible. So next slide, please. So the smart city missions in India, they have a strategy workout. So the strategy is going to be, one thing is about area-based development and another one is a pan-city development. So the area-based development is the particular area. Maybe you have to develop there is a bus stand, right? Or maybe there is a trade center, right? Or maybe a smart park or something, right? So particular area-based development is concentrated. And when it comes to there is a pan-city development, so we have the smart, there is CCTV surveillance systems, right, as well as the smart parking. So those kind of solutions will be also provided. So in India, so smart city missions have the area-based development as well as the pan-city development as well. Right? The pan-city is about across the cities. And also that is providing the strategy, right, in three ways. One is the redevelopment and retrofitting as well as the greenfield. So what is the redevelopment, right? The redevelopment is about for existing, that is an area for about that is in 50 acres, right? So we have to redevelop it, right, with a kind of there is a new solutions, right? So with a kind of there is a new IoT there is a solutions. When it comes to retrofitting, right? So the existing solutions are the existing infrastructures, right? Without altering to them, right? We are going to add a new IoT component. So, for example, we already have this kind of there is a bus stand, or we have there is a parking environment, right? How to make it with a kind of there is a smart parking? So we would employ maybe the CCTV surveillance system. So that will make the parking area, so make it as a smart parking area, right? So with the help of it is a kind of that is retrofitting solutions with that kind of available infrastructure. We would add this kind of there is an IoT component. And we have a greenfield, right? The greenfield is about there is a fresh, there is an area to be identified. Then from that area, right, we could be able to develop the tourism solution. So in that way, the smart city, there is a mission of India is identified, and we have the redevelopment, retrofitting, and then greenfield. what you have selected. So now currently, right, for 100 cities, you can say that the 5,151 there is a proposed projects, and we can say that 3,049 projects with a worth of right 52,449 crores amount, right, it has been right implemented right in the smart city. There is a project, right. You would see that there is a potential, right, how much right the smart city environment, especially there is in India, right. So you have right there is a 52,000 amount of course, and there may be right there is a huge there is investment that also happen, right, because all this kind of there is some corporation they will have the self generation that there is some funds they will invest there is more kind of there is an IoT solutions in the ICC platform and in the smart city project as well. Okay. So next slide. So when we say that there is an IoT, right? The IoT is about Internet of Things, right? So when you say that, right, without the things, right, it is going to be the standalone device. So the device is connected to the internet environment, so it is going to be the Internet of Things. So now you have over there is a mobile devices or phone tab or laptop, right? Or we would say that, right, even you say there is a cameras or a speakers or microphones, right? So even the headphones, right? So not only right in environment, right? We have say there is some smart home environment, we have a smart lock or we have a smart car environment, right? And also we have the smart refrigerator and wearable. There is a sensor like a smart belt, smart shoes, smart shirts, right? So anything, right? If you apply smart purses, right? Anything if you apply the kind of there is a sensors, right, for some purpose, and these sensors is connected to the internet, then it will become a smart device, right? So the Internet of Things mainly core concentrate on this kind of there is an IoT devices. So the main idea of IoT is to globally connect the small things as well as the object, and each object will have an uniquely identification there is a number. So whenever it is connected with the internet, right? So we will have the unique identification code for the IoT device as well. So the interoperability among the devices. So it's not about just connecting the devices, right? And the main thing is about right each device generating the lot of there is a data, and these data are shared among the devices, right? As part of the is a knowledge, right? And with the help of the knowledge, right, we will be able to that is predict and we can control back to the devices. Right? That is very important. Right? It's not about right the devices are connected. So these devices generate a lot of there is a data, and these devices are the data right and using machine, right? So they want some of the temperatures right outside of it. So then we can do it. So when we say that there is an IoT, that is which is a broad term, we can say there is industrial IoT, right? Because many IoT there is a devices are now used in industries as well, right? So in order to control the environment, to control the environment, and also to automate the environment. Right? So there are more automations are happening right in kind of there is an industry with the help of this industrial there is an IoT things. So there is an applications of IoT in industries to modify the various existing industrial systems. So most of the existing infrastructures right has been now modified with the help of this industrial IoT, right? Because of there is a more automations happens. So IoT needs the automation system with the enterprise planning as well as the product life cycles also. So next slide, please. So you can see that right when you can right IoT segment right and the IoT shares right the smart city right runs on the top right. It is the first one right in the smart city which uses the global share of the IoT projects. And so the 34% in America and the 34% in Europe, another 30 and 18% in Asia specific countries as well, right? So another there is countries will share. So as a total, right, as a total, so 23 percentage of total IoT projects right live runs in the smart city environment only. Because there is one of the part, and also right we have connected there is an industry with the help of there is industrial IoT, and have the connected there is a buildings and connected cars environment. So we have ad hoc there is a vehicular network, right? Smart vehicles are connected and smart energy systems. That is very important and we can't able to use the conventional there is energy resources anymore, right? And others, right? And there are also connected health systems. So connected health system like there is a wearable sensor devices, right? With the help of this artificial intelligence and the IoT environment in the healthcare industry is also possible, and have the smart supply chain management like a logistic the entire the supply chain from the warehouse to the consumer, right? So we'll be able to connect with the help of this IoT devices. And also not about only the smart city, right? We have the smart rural also, right? Smart not only the urban areas, we will be able to consider the villages also, smart villages. So with the help of smart agriculture, right? Smart agriculture, right? We will be able to smart livestock management, and smart agriculture means we will be able to employ smart farming, smart precision farming technologies, right? So all that will run in the place, right, in the kind of IoT technologies, right? We will be able to predict the smart agriculture. Smart agriculture is now that is getting the momentum, and maybe probably it may get into there is list of there is the first top five. There is a places in near futures also. Smart retail, right? Smart retail. There is also the help of there is an IoT environment, right? So that is also getting the momentum. Okay. So next slide. So the core layer is about have the Internet of Things that is in devices. So the things about the sensors, actuators, and any device, right? Kind of there is a mobile devices, everything. So that will generate the data. So that generated data with the help of these communication technologies that may move on to the cloud environment, right? For data storage and also for data analysis, analytics, predictions, presentations, report formation, etc. And we will be able to, right, with the help of this, there is a data, we can develop a lot of applications as well, right, for depends on the verticals. So we have the consumers, homes, very smart infrastructures, and then healthcare and transportation, smart transportations, smart industrial environment, as well as smart retail environment, right? So there are many applications has been that is in developed, and with the help of that, right, we can do that is analytics platform. So we have the different there is a layers of there is an IoT, right, environment developed with the help of different applications as well. So next slide, please. So the different layers, right, run through, right, here in there is an IoT. So the bottom layer is going to be the sensing layer. So we will employ the sensor, actuators, as well as the mobile element and so on, right? So that will, right, sense the data, right, that will generate the data actually, right? So these are the core layer that generate the data. So we have, right, a edge computing in place, right? If you want to do the analytics within the device itself, right? If you want to, right, you no need to go for go for an there is a cloud computing, it takes there is a lot of time. So we could employ, right, the edge server. So in place of the sensing layer itself, right? So then from then once the generated the data has to move on, right, to the cloud environment. So for which we require there is a network layer. So all the network technologies, right, has been used, and also fog computing, right, as well as the cloud computing can also take place here. And middleware layer, right, with the help of there is an API, right, the generated data that will be fetched and communicated to the next level, right, to the application level layer. So in application layer, right, we have to develop such applications in a different environment. For example, right, there is a smart retail or a smart healthcare, right, or maybe a smart education or smart there is a security environment, right? So we have to identify the different verticals, right? Accordingly, we will be able to develop the applications, right? So once the application is there is developed and the data is generated, right? So in the business layer, right, we have to do lot of there is an analytics here. So for which we will use the technologies like there is a machine learning, there is a data science, right? So all this kind of optimization, right? So we will use these kind of there is a technologies to predict, right? So it's not about generate the data and see the from the past data we will be able to generate the reports, and also, right, we have to be able to predict the futures also. So that can happen only through this kind of there is a data analytics. There is a platform that runs through in the there is a business layer itself. So these are right, the five layers, right, the sensing layers, network layer, middleware layer, right, that will connect it. So then so the application layer, the business layer that runs through in any platform environment. So we can see that, right, it's not about only the Internet of Things. It's a standalone technology, right? So we have the edge computing, fog computing, there is a cloud computing, and also the machine learning, the blockchain technologies. There are a lot of there is a 5G, 6G, right? So all those kind of communication technologies, everything that runs place with the help of run place in the IoT environment. So next slide, please. So it's time to play the next video. There is an how IoT system will be used in a smart city syndrome. Yes. So it shows different, there is an IoT solutions in different, there is a vertical. So, right, applications of IoT is inevitable in a smart city environment where we, right, because of the growing populations, right, in the urban cities, right. So, and also the infrastructures, there is a development and comes to in a smart city environment. So, next slide, please. Say that, right? So all this individual, there is a platform when we connect it, right? So we have in the bottom layer, we have the different applications, right? So all these applications has to be that is connected and integrated into something like right, a small ITBC there is in platform. So ITBC is nothing but this integrated command and control the reason center, right? So it's not about right, only the right control as well as command. So we have the accumulated there is a data from the different systems, and that data can be used for right real-time reporting as well as for a predictive analysis in the IEEE there is a platform. So there is a purpose right of developing the IEEE platform, and India right all the smart cities will have that kind of there is an IEEE platform in place, and right so there will be a what you call individual ITBC platform, and these ITBC platform will be connected to the state level, and all the state level ITBC will be connected to the there is a central level also, which means right from one place we will be able to control right the city environment, right? Maybe in a Delhi, right? Sitting in a Delhi, right, we could be able to control the city environment, right? City environment for a particular city, maybe Trichy or Tirunelveli or maybe Chennai, right? Or maybe Hyderabad, right? So any locations we could be able to control. So that provisions it helps, right? And also we could see the real time there is a real time monitoring of whole data about the there is a city, right? And not only the environmental monitoring, right? Air quality we could be able to there is a predict, solid waste management we could be able to predict, right? Yeah, traffic environment we could be able to there is a predict, right? So how much there is a water is there is pumped for a particular day, right? We could be able to there is a predict, right? So we could analyze and then we could be able to predict the data with the help of there is an IEEE platform, and all the locations are there is a geo tagged, right? And we could be able to monitor the locations also, right? With the help of the CCTV surveillance and so, and also with the help of so not only to the authorities, right? So the citizen corporation authorities as well as to the government. So we are also providing lot of that solutions to the citizens also. Right? We have right, the citizen platform. So all the services are provided to the citizens, right? They don't need to go anywhere, right? So the simple there is a mobile app, the city app, right? So they can avail all the services provided by the city environment. So that's the provisions given by this ITBC there is a platform. So this is a holistic approach of the ITBC platform, right? We have the state level command and control centers, and all these services are right mostly hosted in the there is a cloud platform, right? So we have the common cloud based there is a data center running for there is in each city, right? And these right the data center will accumulate all those kind of there is in data, right? And it will analyze, right? And it will store, process, right? And as well as the predict the data in the cloud environment. Okay. So next slide, please. So IoT application in a smart city environment, right? It's varies in again the different environment. So we have the smart homes, demand and response. We could be able to predict the fire detections, temperature monitoring, the security, especially right when harm to that is making the home environment right. Security surveillance is important, and most people are now using right the CCTV surveillance itself, and smart parking as well as the healthcare applications development, the tracking, identifications, data gathering as well as the sensing applications, and we have a weather as well as the water distributions monitoring system as well, right? So we have the water quality, and we could be able to identify the water leakage, right? And what is the water level of a particular there is a tank or something, right? Water contamination. So whether there is any poor quality of the water, right? We could be able to identify in a real-time manner, right? Also transportations and where there is a traffic, right? We would be able to predict the real-time traffic, and we would give that there is an alternative way, right? And also environmental monitoring like air, water, and land, right? So everything could be there is a monitor with the help of the sensors and the actuated devices, traffic jam reductions, assisted driving, and also there is environment, there is in pollution, renewable energy uses. And this is core important for every city, right? To control there is an environment, right? Pollutions, noise pollutions monitoring, air quality monitoring, energy efficiency, right? Because more number of these devices, street lights has been used, right? So how to employ with the solar street lights and how much energy it is generated, how much energy is consumed per day, right? So all these kind of things, right, can be derived with the help of the IoT technologies. And especially right when it comes to there is a police department, right? So we could be able to provide the CCTV surveillance, human detections, crowd detections, right, thief detections, right, violent detections. So public place there is a monitoring and people object, people tracking, right, would be able to identify the people's also, right, and there is a trafficking, right. So everything, right, all this right applications will be developed with the help of the IoT environment in our smart cities. So next slide. So IoT is a kind of an ecosystem. It's not only the IoT technology, right? We have a software-defined networks here. So once it generates and there is a data, right? How to process data? We need a cloud technologies here, and right in order to store the data and process the data, we need a big data because it's going to be a real-time environment to generate a huge number of data. So we have the big data environment and how to communicate the data. We have the 5G, 6G technologies, right? And we have the safer physical systems, right? And telemedicine when it comes to smart healthcare and machine-to-machine communication. So all the IoT devices, right, has to communicate, right, not only to the IoT environment to the server up to the human, right. So the devices itself, right, start to share the communications, right. So that's why we have the M2M model, right, and then we have the internet of the vehicles, right, smart grid environment. So not only the cloud, right, the fog computing, right, grid computing, and also right that is edge computing is also take place in the IoT assisted technology environment. So next slide. So there are right when it comes to right the technologies point of view, right. So there are more standards which should also level, right. So IEEE standards help enable the smart city technologies for humanity. There are many right, the IEEE standards about right, especially for a smart city there is an improvement. So even for Internet of Things and for a 5G right, and also for a cyber security, e-governance, smart home and the learning technologies and so for e-health and then energy efficiency. So we have several IEEE standards and then guidelines. So these standards has to be adopted. So in the smart city, there is an environment right, in futures. So next slide. So IoT is not a technology, that is a kind of there is a particular technology, it's a kind of ecosystem, right? So because it can be applied to most of the verticals, most of the domains, right? In the areas, right? So it's kind of connected. There is a technology, right, to all the applications in government. Right? Smart planet, smart cities, smart buildings, smart transport, smart energy, smart industry, smart health, as well as the smart city and smart living environment to the resident citizens environment. Next slide. So there is a 15 million connected devices by the year there is an year 2025, and it's not about the things, right? So it's not just about there is a connecting devices, and these devices are actually generating the data, and we will be able to control the devices, and we can do more predictive analytics, right, with the help of this IoT generated that is the data as well, right? So it provides a lot of services as well, right? It's not about just connecting the devices, right? These devices provide a lot of the different services, and there is a huge market position potentials available in the IoT, that is a smart city, that is an environment, right? So 95% of right the CEOs so survey that there are planned to use IoT in there is a business logic, right? Which means right. So there is a huge potential in adopting IoT technologies in there is a business logic itself, right? Because there is whatever we discussed, right? So it's about the technology, the paradigm, right? Which has to be adopted, right? Not only in the smart city environment to all the right the technology, all the there is a verticals and there is applications as well. So next slide, please. Yes, these are some of the books publications, right, with related to the smart cities. Edited by me, right, there is a handbook of research on implementations of deployment IoT projects in the smart city environment, and two books from elsewhere as well, right. It is one is a handbook of research on blockchain technology, and another book titled specifically blockchain for smart cities. How we can use the blockchain technology, right? So not only the blockchain, when it comes to there is a blockchain, the IoT environment also comes in place. So how we can use the blockchain for there is a smart cities, and how we can right reduce the energy with the help of green engineering. So handbook of the green engineering technologies for sustainable the responsibility, because these IoT devices will generate right, and also consume there is a more there is an energy, right? How to right, reduce those energy, right? With the help of there is a green engineering technologies, we have to right, deal with them. Okay. So yes, this is about my presentations. So thank you very much right, for giving the opportunity to present right, my session here. And in case of any queries, right, I am happy to assist with you.
Thank you, sir. Thank you, sir, for sharing wide knowledge about smart cities
Yes, ma'am.
and about IoT. Any questions from participants? Sir, one question posted like this.
Okay.
What kind of tools to be created for the support and measure of the diversity required?
For the supporting measure of
Support and measure of diversity required.
supporting measure of diversity required. So,
Support
is it,
and
okay, talking about the tools, right? There are many tools available, many tools, many
yes.
frameworks available for a smart city. There is an environment. It's again, it's depends on each city, because each city has to identify those verticals from where they are going to implement the solutions. So depends on the solution, right? We have to identify the technology, right? For example, I'm going to employ right the smart there is a surveillance system, right? So then we have to use right the CCTV surveillance. There is in cameras. So we have to use advanced digital image processing. There is a technologies, right? So accordingly, we would employ the tools. There is a frameworks, right, and the technology paradigm and so on.
Okay. 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 Sir, one more question, sir.
Yes.
How to include that includes basically illiterate and retired people into the smart city segment?
Yeah, that is actually going to be there is a challenging. Right now, people start using the mobile phones and then access to other services. Like so, similarly, right, we have to train them right to avail these kind of the services also. Because if the services are available in the mobile phone, that will be very handy, right? Again, the senior persons or illiterate people, right, don't need to that is go to the and also right, we would be able to simply converts, right? We have a lot of there is a Google Translate engines are available, right? We would be able to simply translate from there is English to there is a to Tamil or to there is a Telugu or to Malayalam, right? So any conversions with the help of this kind of technologies, right? We would be able to convert. So not only to the senior citizens and also for physically handicapped peoples also we can assist them. Yeah, yes, ma'am.
Yes. Sure, sir. Thank you. Thank you, sir. Thank you for your answer.
Shall I? Very glad to listen to your session, sir. It was very informative. I have a small query, sir. I would like to know your opinion, your comments about the security and privacy issues, sir, and how acceptable it is in our Indian culture for these smart devices. What is your comment, sir?
So security and privacy, so it should be there, right? As long as we have the connected devices, we have the internet, right? So once you connected to the internet, right? So definitely there will be an issues with the security and privacy. That's why we are dealing with it. It's more kind of there is an security assistance, right? Logins, right? Single sign-on, and also the privacy, how to deal with it. So many kind of there is an algorithm and solutions are developing it that can tackle this kind of there is a problem with the security. So when you say that right, maybe if you, more number of applications are growing, right, people would be right more there is a cautious, right, cautious about dealing with the data as well, right. So the most of the problem arises because of the right people and for people that they mistakenly handling these kind of the risk data. So some sort of training is needed. So most of the people right now today, right, are following that literate or how to deal with the data don't have the problem with handling these kind of the negativity devices. It is only the small portion of the people, right, who don't know how to deal with the kind of the risk devices and so on, right. So the proper devices and then proper algorithms, so those kind of strategies needed for this.
Thank you so much, sir.
Yes, ma'am.
Sir, now I would like to summarize your talk, sir. Sir has given with a talk with opportunities in smart market and requirement of more services in many domains. And there is a need for developing integrated applications in many domains. And Sir took us through evolution of smart cities through from early stage to entire growth with a very informative video. So, with a very informative video, Sir has given what is a smart city and how can it is used with different countries and it is used in different countries. And industrial IIoT is a new concept which we have listened today. Links the automation system with the enterprise planning and product life cycles. And Sir has talked about the layers in smart IoT and IoT systems using one more video. So, thank you very much, sir, for your enlightenment with smart cities. Sir. Thank you.
Thank you, ma'am. Thanks a lot. Thank you.
And sir, we are very happy to invite you for the two-day international conference conducted by Stanley College of Engineering and Technology. Please do join with us, sir, on 15th and 16th. And
Yeah, sure.
one more thing, sir, appreciation letter of this stuff will be sent to your email, sir. Please accept
Okay.
it, sir.
Yeah, welcome. Thank you.
Sir, the next session starts at 2 p.m. Sir, we request you to join with the next session also, if possible.
Yeah, sure. Yeah, sure.
Thank you very much, sir.
Yeah, thank you.
All the participants and delegates, it is informed that the next session starts at 2 p.m. All of you are requested to join by 10 minutes before. Thank you. Thank you.
Audio Jungle. 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 Audio Jungle.
Conference. Faculty.
Audio Jungle.
From attending.
Audio Jungle. Audio Jungle. Audio Jungle. Audio Jungle. Audio Jungle. Audio Jungle. Jungle. Audio 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 Jungle.
Good afternoon, Dr. Muruganathan, sir. Sir, are you able to hear me? Sir, I think you are in the listen mode, sir, if I'm right. Dr. Murugappan, sir. Good afternoon, sir. Dr. Murugappan. Good afternoon, Dr. Murugappan, sir. Am I audible to you?
Welcome, sir.
Yeah, hello, ma'am. How are you? Hi.
Hello, sir. Good afternoon, sir.
Yeah, good afternoon. Sorry, actually, I'm currently in my university, so the university network blocks. So I use my hotspot now.
Okay, sir. No problem, sir. We will start the session, sir, now.
Yeah, sure.
Okay. Good afternoon to all the delegates and participants. I welcome you all to the AMSC 2021 conference keynote sessions, day 3, afternoon session. Now, moving on to the next keynote session, it's on effective computing systems for neurological disorder diagnosis. I would like to invite Dr. M. Murugappan, sir, Associate Professor, Department of Electronics and Communication Engineering, Kuwait College of Science and Technology, for delivering the lecture. Welcome, sir. It's my honor to read your profile, sir. Dr. M. Murugappan has received his ME in Applied Electronics from Anna University, India, and PhD in Mechatronic Engineering from University Malaysia Perlis, Malaysia, in 2006 and 2010, respectively. Currently working as an associate professor in the Department of Electronics and Communication in the College of Science and Technology, Kuwait, since February 2016. He has gained more than 11 years of post and research experience from different countries like Indonesia and Kuwait. Prior job to KST as well as School of Electronic Engineering, University Malaysia, Perlis, Malaysia from 2010 to 2016. He has received several research awards, medals, and certificates on excellent publications and research projects. Recently, he has been included in the top 2% of scientists in the world experimental psychology and artificial intelligence by Stanford University researchers. He has published more than 120 research articles in peer reviewed conference proceedings, journals, and book chapters. He has got a maximum citation of 4,375 and a H index of 33 and a I-10 index of 72 in Google Scholar citations. He secured nearly $2.5 million as research grants from the government of Malaysia and the Kuwait Foundation for Advancement of Sciences, Kuwait, for continuing his research works and successfully guided 14 postgraduate students, 9 in PhD and 5 in MSc. Welcome you, sir.
Yeah, thank you so much, ma'am. Thanks for your nice introduction. Yeah. Actually, I switch off my video because the bandwidth is consuming a lot and your voice is not audible to me. So when there is a question and answer session, I will open up my camera. Is it okay?
Yes, sir, it's okay, sir.
Okay. So how to proceed? Do you give me an access to show up the
Yes, sir.
presentation?
Yes, sir. We'll be making you as presenter, sir, so that you can upload your PPT.
Yes, yes.
So you're given the access now. You're given the
Okay. Okay.
So can you see a button at the bottom, sir? The fourth button to the right, like the last button. You'll have a button after the camcorder symbol.
So far, I didn't receive. I have
Ma'am,
only
actually,
the yeah.
this below one, I think you have to make as presenter, ma'am. Actually, sir had joined with 2 sessions.
No, no, no. I will close one. Now, yeah. Now I close
now
it.
you
Sorry.
can. Yes, sir.
Now I can see. Now I can see. Yeah.
You can just click on that symbol so that.
Yeah. Can you see my screen? Yeah. Okay.
It's buffering, sir. Just a second.
Can you see my screen? Yeah.
Yes, sir. Now it's visible.
Okay, fine. Actually, please remind me if I'm going out of the time, okay? Because I may be too enthusiastic when I'm coming to the research presentation. Okay, so without further ado, so thanks for your invitation, first of all. It is a great pleasure to give a presentation at your first international conference. I was looking at your progress and the way of organization. It is, extraordinary. It won't look like a first international conference. It's like a very professional, and a big congratulations to all the organizing committee members. And thanks to the organizer for giving me a nice introduction. Okay. And actually, this has been covered already. So now I would like to move on to the topic of adaptive computing system for neurological disorders. So the outline of my presentation starts with the introduction about affective computing. It includes the definition, models, what are the varieties of applications, statistics, and what are the design process we have to follow, and what are the types of systems available. And then we move on to clinical application. In clinical application, in this particular presentation, we will discuss about the neurological disorder, especially Parkinson disease. And then I will show you some of my experimental results, what we are working on, and the challenges and future scope of the particular research, at present moment. And then finally, we end up with the question and answer session. Okay. So before I like to begin my presentation, effective computing is one of the very interesting area. I was started working on this domain since 2007, and I was started working with the clinical application since 2013. So we have gained a very good amount of experience, and we are developing a system to assist the clinical people or physician at the hospital for the diagnosis purpose. So we are working on many areas in neurological disorder. I will show you all these things in the coming slides. Okay. So first of all, if you are not much familiar about this topic of effective computing, if you look at the literature, it has been first introduced by Professor Rosalind Picard at MIT lab in 1995. She is the one who has introduced this field of effective computing domain for different or varieties of application. In other words, we can also define this effective computing as an artificial emotional intelligence. So basically, in this field of research, we are trying to understand and appropriately respond to the people affective states, basically emotional states. So the core idea of the affective computing is to how do we decode the human emotion by using a different kind of behavioral or physiological responses. As in our day-to-day life, we used to communicate. Emotion is one of the very important medium for improving the interpersonal skill and also the social interaction with the others, right? So there are different kind of modality has been started investigating about this particular emotional state identification, right from facial expression, gestures, and physiological responses and speech signal. So these are all the varieties of mode we use to understand the people emotion. In order to develop a diagnosis system, we are basically looking for a decision-making process. Okay, so the decision-making process has been purely managed by the machine learning or recently by deep learning. In generally, we use artificial intelligence method, because artificial intelligence method is one of the very, very important role in the case of effective computing system. One of the important reason is affective states are highly subjective and highly transient. What one person realizes the emotion when he is at one particular moment is not the same as the others. So emotion differ. It is completely a subjective phenomena, and also it is a transient phenomena. When you want to analyze this kind of transient and highly subjective data, we need to go for AI methods. If you recall the role of emotion in our day-to-day life, it has been widespread over in all our activities. It starts from decision making, memory, creativity, intelligence, social interaction, and perception. Everywhere emotion plays a major role, right? And when you look at the field of effective computing, it is highly interdisciplinary research. So we people are basically a computing researcher. We always work along with the computer science and also the psychologists and biomedical engineers. So it is a highly interdisciplinary research. So the reach of or the contribution, whatever we made on this field of research, is completely benefiting many people. And also, it also get a wider readership. That's what I understood from my experience. When you talk about emotion, even though there are huge and larger number of classification is possible, basically we classify or group the emotion into 6 basic categories. So, such as anger, sadness, surprise, fear, disgust, and happiness. So, we are trying to model all this emotion under this 6 category, and we try to develop a system to understand any one of this emotion in our real life. Okay? So, if you look at the modeling, because since there are huge number of categories of emotions are there, people are trying to model the emotion either a two-dimensional axis for the sake of simplicity, or they can go for three-dimensional axis. So the two-dimensional axis, which is about the valence arousal. The valence arousal is basically referred to identify or understand the intensity of the emotion and the magnitude of the emotion. Actually, for example, you may have if you look at any movie, you may feel happy or you may feel sad, but that is one of the very important category. Okay. Besides that, how much you realize in terms of fear or in terms of happiness, that is another important scale that also need to be considered. So basically, we talk about the valence arousal axis to identify the emotions. Okay, either positive emotions or negative emotions. Is it a high or low? Based on this, people have developed a universal model to group the emotions. When you look at this emotion, as you can see, the happy and surprise emotions are in the high arousal and high valence. That means it is considered as the positive emotion. Whereas sadness, depression, bored, and disgust, and all comes in the negative axis, which is, you can say, negative valence and low arousal. So if this is the two extreme condition, usually we want to consider. What happened, because all kind of common neurological disorder are relying on these factors only. A simple example is the bipolar disorder. If you look at the bipolar disorder, people are either extremely happy or extremely angry. So they have emotion, but the emotion is very strong. It can either go to positive way or into the negative way. So these kind of things become very common. So why the bipolar disorder happen? If you there because there are many neurological disorder are not a genetic disorder, especially Parkinson disease and all. It's not a genetic disorder. So here, when the people are in the negative emotion over a prolonged duration of time, obviously they have a stress, and this stress is what we call as emotional stress. Sometimes we call as anxiety. Anxiety is another kind due to the pressure, mental pressure. But due to usually we refer this stress due to this emotion is called as the emotional stress. So this is one of the important way to identify and understand how is the people emotions are varying. Because it would be very difficult to classify the emotion into discrete classes or 6 types, what we saw in the previous slide. So it would be easy to model either in the valence arousal axis. That's why most of the researchers are focusing on dimensional mode of classification. Sometime in the recent years, in figure 5, you can see that the people are using the three-dimensional mode, which also look at the dominance. For example, you feel happy, you feel happiness for a moment of period of time, okay? But at the same time, you're also realizing the other emotion between the time. Okay, in this case, we need to also understand which emotion is dominating during the period of time. Okay, so this is the major important core idea behind the effective computing system. If you look at the application point of view, there are varieties of applications possible, and there are huge number of applications started emerging. It starts from marketing, customer service, human resource, retail, insurance, government, gaming, and education and healthcare. Okay, so we are working on selected applications from this particular figure, and this particular topic is purely related to healthcare. So I would like to stress more on that particular part during this presentation. Okay. So if you look at the projection of or the significance of effective computing in the post-COVID scenario, after post-COVID scenario, things are changed, drastically, because many things has been changed, and one of the important thing is the online education, right? E-learning. So at the same time, the people have projected what is the growth of effective computing system after COVID, post-COVID scenario. As you can see, in 2020, it was the investment expected around 28.6 billion US dollar, but in 2025, people are expecting 140 billion US dollar. So this is one of the very important market, okay, or one of the very important technology that plays a very major role in terms of drastic or vast growth in the future. Okay, because nowadays people are understanding and realizing the importance of computing technology, especially effective computing. Because as you can see, one of the basic reason in the healthcare sector, effective computing system is growing tremendously. Because after the post-COVID, there are so many problems that have been arising, and people are interested to understand the behavior. For example, psychological behavior, mental behavior, physiological behavior, psychophysiological behavior. All these things has been connected with effective computing. And this is one of the very important figures that shows the worldwide map of how the regions are growing. What are the regions are investing in effective computing? As you can see, the region of Asian country, it is investing a lot, okay? Australia, India, China, and all these countries are investing a lot in the field of effective computing. And then the African countries are the lowest investment in this field of effective computing. And now we come to the methodology. What is the basic idea? How do we develop a system? So basically, we need to understand what kind of behavior we are going to monitor, okay, or we are going to assess. Okay, is it a micro or macro or physiological? So is it facial expression or a speech or a gesture or physiological? So you need to know basically how you are going to assess the emotional behavior of a people. After the identifying the methodology or the tool, we have to identify, is it invasive or non-invasive method? Okay. For example, facial expression. Facial expression can be captured non-invasively through camera. At the same time, you can also use facial EMG signals. That is another way. Or you can use the reflective marker, okay, or a fixed marker. This is invasive. So there are two kind of things are available in the world. Is it invasive and non-invasive? So it depends on the application, okay, what you want to use. After that, when you develop all the methodology to understand the behavior, we go for decision making, which is using the AI technique, which can be either supervised or unsupervised or semi-supervised method. That could be used to identify the emotions. Okay, this is a simple overview. When you look at the things what we discussed in the very early, facial expressions are one of the most important and common kind of emotion assessment. Over the last 2-3 decades, people are using the same technology. Until now, people are using facial expression because it is a non-invasive, very comfortable, and in the investment point of view, it is a very low cost. You don't need very complex systems. And later, people are trying to use for speech signal for security purpose. So security purpose, people are using the emotional speech, recognition method as one of the security feature in the recent years. After that, the most common type of signal or most common type of modality where it plays the role in healthcare in all other application is biological signal. It could be a ECG signal or EMG signal or EEG signal or PPG or EOG, electroencephalography, whatever can be. Whatever may be the type of biosignal, it is completely non-invasive and it is more reliable and it gives you more useful information about the physiological changes. because in the previous modality, facial expression and speech and gesture, it could be easily you can hide the emotion. Though you may not happy, if you smile, people understand, the system understand you are happy. Okay, though you are not happy, if you speak a very funny word, people think that you are happy, right? So, but it is not possible in the case of biological signal. That is one of the beauty. Okay, so we could get more reliable information where the person doesn't have any control on their limiting their emotion, okay, expressions. So if you look at the unimodal system, people are trying to use any one of the, this is a one of two kind of system we people are trying to develop, either a unimodal or multimodal. When you come to unimodal system, people can use either a speech signal or people can use facial expression or biological signal to analyze or to capture the emotional behavioral sample. Once the samples are collected, we could use the pre-processing technique to remove the unwanted information. Because most of the existing systems are developed in the laboratory environment with the selected constraints. But when you come for developing a system into the real world, you will face a new scenario in terms of, and you should be, your system or your methodology, your algorithm should be more robust in terms of handling the noises. So one of the common and most common approach and popular approach so far people have used before 2018 is the machine learning approach. So they remove the noises, they extract some statistical characteristics of the signal, they use the feature reduction technique to optimize the features, and then they give it to the classifier to classify the emotions. So it is a kind of one-way process. We are not using any kind of feedback approach here. Okay. So, but recently people are come up with the use of deep learning approaches. So the deep learning approach attracted many people since the computing systems are emerging a lot in terms of the hardware design, and people are trying to use the deep learning methodology for more effective and more robust system development. Since the computing power is not a matter, so people are looking for deep learning approaches, either by pre-trained network or they develop a customized network to classify the emotions. Okay, so one of the biggest limitation here is the data size. It would be very difficult to collect the biological signal. If you say take a biological signal, it would be very hard to develop a huge amount of samples. Okay, that is one of the biggest limitation when you go for deep learning. Okay, and when you come for multimodal system, it is more reliable and more robust. So since because you are not only relying on one modality or one mode of information, you are also depending on multiple modes. So you are looking for facial data, speech data, and biological data. So this could give you more effective information compared to a single or unimodal system, right? And the rest of the things remains the same. So we can easily try to classify based on the input multimodal data. So when you come for biological system, as I said earlier, since the gestures, facial expression, and speech signal have a lot of limitation, and if you want to develop a more reliable and robust system, you need to go for biological signal. If you go for biological signal, we have some challenges. One of the biggest challenges is the effect of noise, because the signal is basically a low frequency signal and it is it is highly subject to the effect of noise. So you need to develop a very efficient technique in order to effectively remove the noises from the signal. Actually, we are not removing noises completely. We are reducing the effect of noises. That's what we do. Once we do that, then we have a lot of methods are available for future extraction, either a time series approach or time frequency approach or frequency domain approach or spatial features. So you could able to get more effective features from the biological signal, and then you can apply you can apply a feature reduction technique or feature selection technique to select the optimal feature, and then you can classify the emotion. So this is what the conventional way of flow, what we use basically in the field of biological signal based or physiological signal based affective computing system. When you come for healthcare, there are varieties of applications possible using the mode of affective computing. Mainly, we use these systems for patient care. People have developed here like a kind of bot, a chat bot, okay, that could be used to remind the patient to take the medications. And also, it can monitor the physical and emotional well-being of the people every day. And also, it observes the behavior of the people and it communicates to the remote healthcare worker or hospital or whatever it may be. This could be one of the systems where the Western countries are mostly using for improving the well-beingness of aged people. Because many countries, the loneliness is one of the major reason for depression. So I thought of telling you one more thing, when you talk about emotional stress. So what is the problem? Okay. For example, some people are subjected to negative emotion. For example, sad or anger or fear for a prolonged duration of time. So it induces the stress and they could not able to understand the stress at any cost, any point of time. And if they don't treat that particular stress at a specific period of time, what happened, the people usually trying to attempt for suicide. So in many countries, when I was working in Malaysia, so one of the one of the important reason to start this work is to reduce the suicide attempt by the neurological disorder patients in the hospital. Okay, that's because this is what we call burnout state of people. And then after the patient care, we go for medical diagnosis. So as you can see, we have a system that could able to diagnose the emotional disturbance of a people. Okay, then we can also use the system for counseling. This is most common in nowadays, where for psychological counseling for any kind of neurological disorder people or psychological problematic people, for improving the well-beingness. And besides, some of the countries, they are also used to monitor the pregnant woman, well-being of the pregnant woman when you want to care about the people. Okay, so when you look at the remote video conferencing method based diagnosis, we also use the affective computing system for Alzheimer's disease people. These are all some of the systems which are existing in the market. So I would like to show you some of the application, okay, about general application. Then I go to our own application. So the deep effects is one of the system which has been developed by US, which is mainly used to capture the facial images of the people. After capturing the facial images, it will analyzes the blood flow in the facial region of a specific region of the face. And based on that, it tried to identify the people emotional state, behavioral changes, BMI, then the blood pressure, and the chances of getting into stroke and cardiovascular diseases, and many more. So this is one of the kind of system that could able to easily analyze the people well-being in a remote environment. So they no need to aged people, they no need to come to the hospital. They could able to easily analyze their behavior or the well-beingness through the systems. And another one system is called Empatica. It is also one of the most powerful tool which has been used for remote diagnosis. So when we are talking about aged people, especially talk about the neurologists and all, there is a very, very limited number of neurologists in many of the country. It would not be possible to provide the clinical healthcare to all the people in remote area. So when you want to develop a intelligent system that could be able to monitor the aged people, so this kind of remote healthcare system is used to monitor by using the sensors. So nowadays people have started using the wristband and the smartwatches. So the data has been collected from the smartwatches and has been communicated to the remote server through internet and cloud computing method. and the server is also connected with the cloud environment so that the doctor could be able to easily monitor the patients. So this kind of systems are very, very important, especially for neurological disorder. If you come to the statistics, why we need to care about neurological disorders? As you can see, there are 1 in 6 people in the world are basically or commonly affected by neurological disorder. According to the recent report at UK, it shows that there are 14.7 million neurological cases are spread over the world. And among the men and women, and men are has higher chances of getting into the neurological disorder compared to women. And the age-wise, when you look at the right bottom of the figure, the earlier the age after 50, okay, usually getting affected by the neurological disorder. Most commonly after 65 years, people are usually subjected to neurological disorder. But nowadays, the things has been tremendously changed. Even there are some reports available in the world that shows that the people with the 40 years, 45 years, and even 38 years got affected by neurological disorder. So it is because of the way of living, the cultural environment, everything changed the people lifestyle. That could be one of the reasons for getting into this kind of disorders. And when you come for neurological disorder, there are many types of disorders available. One is the multiple sclerosis and the stroke, epilepsy, Parkinson, brain tumor, Alzheimer, amyotrophic lateral sclerosis, and autism spectrum disorder. There are many neurological disorders are there. Then what is the basic problem? One of the biggest problem here is the emotional impairment. Impairment in the sense that people could not perceive the emotion, they could not understand the emotion, and they could not express the emotion. So this is the problem. They could not perceive, understand, and express it. When these problems are is going to happen when the people are affected, this is not a problem which comes over a period of time. It is usually common after the person subjected to any disorder. So any sudden disruption in the brain network usually affect the emotional understanding. So when the people emotions getting disturbed, obviously the people are trying to be more isolated, and they are going to be into a very critical state if it is not identified or diagnosed at the early stage. So for any neurological disorder, it would be very important to understand and then to have to identify what kind of problem, emotional disturbances they have. If we know the problem, we could be able to give a good medical medication to improve the well-beingness. That's the objective of all our research work. So in this work, I would like to talk about the Parkinson disease. When you look at a Parkinson disease, it is basically a neurodegenerative disease, which is commonly occur in the aged people. And until now, there is no perfect cure is available. However, there are different stages of Parkinson is there. Stage 1 is called as the very mild stage. Usually people do not understand they have a PD when they are at stage 1. If people are able to identify they are at stage 1, early stage, it would be very easy to recover. It is very easy to give a treatment. But usually what happens when the people go above the second stage only, they try to understand that they have a PD. By the time it will be very impossible to recover them back. So that's why all the people in the at present world are giving a medication to control the symptoms. So the symptoms are basically a tremor and posture variation. They could not stand properly, as you can see. They could not stand properly. They could not speak properly. There is a tremor, there is shaking, hand shaking, vibration. It's all become very common when they become a PD. Okay, so since the PD people, one of the another important problem is they could not express any emotion from the facial expressions. But unlike other kind of disorder, these people cannot express their emotion through facial expression. That's why we call us expressionless people or facial masking people. So in those cases, it would be very hard to use the conventional methodology to identify the emotional disturbances. So we need to develop a system which could identify or understand or to monitor the emotional changes inside the people through biological signal. That's the reason why we try to go for biosignal based approaches for this particular research work. So this PD is most commonly due to the loss of dopamine chemical. Dopamine is one of the very important chemical which is called as the transmitters, which is used to convey the information from one neuron to another neuron. Because we have billions of neurons in our human brain, so the information has been transmitted from one neuron to another neuron. There, dopamine plays a major role. When the dopamine dies out, so obviously there is a disturbance. So this is what we try. This is what one of the basic reason for getting into the PD. And yeah, okay. Let us look at what is the current procedure. Okay, why you need to develop a automated diagnosis system. When you look at the current scenario at the hospital, people are coming up with the symptoms. So the doctors are diagnosing based on the symptom, and then they send the patient to the standard clinical practices. It can be an invasive procedure or a non-invasive procedure, blood test, urine test, and MRI scan and CT scan, whatever it is. And besides, they also use some international standard questionnaires. So based on all this report, clinical evidences, and also based on the questionnaire, the answers to the question from the patient, the clinical people are trying to identify the stage of what is the stage of the PD and what are the problems. And then they give a treatment, okay, in order to reduce their symptoms or reduce or improve their well-beingness. This is what usually happen in the clinical settings, you know. But in the case of adaptive computing work, what we do, once we know the symptom of the people, which is referred by the physician, we collect their behavioral sample. There are people who are doing the data collection with the speech in the Parkinson disease, or they collect the posture variation, but we collect the signal, biological signal, physiological signal from the PD. So you can collect any kind of information from them which reflect the emotional changes. Then it will be sent for, we have to use either invasive or non-invasive methods. And finally, we try to come up with some decision, and that decision will go to the physician. So the methodology, what we try to develop here is going to give a second opinion to the doctor. We are not bypassing the doctor here. We are just giving a second opinion, okay, in a non-invasive way or invasive way. Then the doctor will choose a proper treatment. This is what currently existing in practice. But in the future, we strongly believe that if you develop an intelligent system with the power of computing and artificial intelligence, we could able to directly give a treatment to the people. It could be possible, you know, it could be possible in the near future. Because since the people have started working enormously over the world, so it would be always be available to develop an self-diagnosis tool, okay, to the patients. So when you come for brain, human brain, okay, there are different regions of brain. So I don't want to go in depth on the medical part. If you look at the different emotion, as you can see, amygdala and the frontal cortex are the most important region for most of the emotions. Okay, so occipital lobe, amygdala, which is over, actually, as you can see from the figure, it's a very, very small region. So that will be the control center of the human being for different kind of emotion. So when you want to understand the emotional behavior of the people, it will be always be more reliable to use the brain signal information or brain imaging information for your diagnosis. Okay, and fortunately, we are started using the electroencephalogram, that is a brain's electrical signal for our diagnosis. Since it is more, there are many advantages why we use the EEG. Even though EEG is not it's not a very good method compared to MRI or CT scan, but still it is more useful because it is less expensive and more robust and reliable, and it gives you very accurate information as closer to the other imaging modality. And we could able to do the experiment at many different settings, because fMRI, MRI and all, it is impossible to do the emotional trigger assimilation process and then data collection. So that's the one of the reason why we go for EEG signal. So we capture the EEG signal from the people. I like to show you. Yeah, this is one of the experimental setting what we had during in the hospital. So we try to use the wireless EEG cap, because this is actually we have used only a 14 channel EEG system for our experimental work. But when you come for this kind of clinical diagnosis, it would be always preferable to use the higher number of electrode, more than 128 channel or 256 channel, for more accurate and reliable information. Since due to some constraint, we used to start with the 14-channel wireless EEG system. This system has been clinically approved by FDA, and it is most extensively used by many researchers over the world. And it is purely a wireless device, so it gives you a lot of flexibility to the patients. They no need to sit on one place and continuously watch the video, okay, of different emotion. They can able to feel relaxed, and it will not harm them at all, and it will not give any negative feedback to the people. So the green colored dots in the figure 14 shows the location where we place the electrodes on the scalp, and on the figure 15 shows how we induce the emotion. Basically, here what we do here is we simulate the emotion, and we capture the information, and we analyze the information, and we correlate with the feedback. In that way, we develop our system for our neurological disorder people. And then just go back now. Okay, when you come to a research problem, okay, how we can analyze the problem. We have normal people, we have Parkinson people. So of course we need normal people for benchmarking. Okay, so we need to collect the normal people who are on the same age, same education level, and same gender, and so many other aspects. Once you collect your quality of data, good amount of data, we could first investigate whether the collected signal can distinguish the PD and normal or not. That's the most fundamental question, because PD have a different characteristics than normal people. So first we need to understand whether the people are basically having a different behavioral characteristics, okay, from the EEG signal point of view or not. In that way, we use the rest state EEG signal, which has been collected at the time of beginning of the experiment. Okay, when they close their eyes, we just collect the rest state EEG of normal and PD, and we try to classify, okay, whether there is any differences or not. If there is a difference, then we could trust on the signal. This is the way in which we try to analyze it. After the rest state EEG, we could also classify the NC and PD by emotional EEG signal. This is another approach. After you understand the variations between the NC and PD, we try to go for emotional classification. Okay, what is the emotional differences within the NC and PD, and then what is the emotional differences between NC and PD for a specific emotion. In that way, we develop a lot of research question to develop a more reliable system. Okay, in our lab. Okay, and as I said earlier in the earlier slide, the system methodology has become very simple. So first important thing is we have to collect the database. Once you collect the data, we have to remove the noises using a filtering method. Then we extract the statistical properties from the signal. Then we use the statistical analysis technique to validate the features, and then we classify the emotion. Once the performance of the system is very good, then we deploy the whole methodology or algorithm into a software prototype. So the way we develop a system is we develop an algorithm where we have a hardware device. So it is usually a combination of a hardware and a software algorithm that could be given to the hospital for the diagnosis purpose. Okay. And okay, pre-processing, as you said, as I said, the effect of noises become more dominant in biological signal. So, but we in our work we use very simple method because we could not spend much time on the pre-processing, since if you do most efficient pre-processing method mean that may affect your original information. That's we have tested with a different methodology, and finally we ended up with a very simple butterworth filtering to remove the noises, okay, for the low power frequency noises, and then the power line interferences, and also the the artifact. The artifact is one of the very important thing which affect your the signal quality, in this case of PD people. The artifact means whatever the movement the person do during the experiment, that's all considered as the noises. Because when the person hand is shivering, or when he started shaking his body, if he started rotating his head, if he started rotating his eyes, everything is considered as artifact, because we are collecting the EEG signal. So whatever the movement you do, which all create the artifact, which is of having a very large amplitude information in the signal. So we should able to handle this kind of artifact to the maximum level. Okay, that's one of the important thing we learned from this work. And the frequency band, since the biological signal, each signal has its specific information for reflecting the cognitive activity. When you come to EEG signal, there are 5 frequency bands, which are very commonly useful for a variety of application. But in our research related to Parkinson disease, the high frequency band has become more common and very important for emotion classification, such as alpha, beta, and gamma. Or in other words, the frequency from 8 to 49 plays one of the important role. Actually, this is a frequency setting that we have used, okay, and it satisfies the universal standard. Sometimes people say 30 to 68 is the gamma. But however, if you are analyzing from 30 to 49, it is also inside the universal standard definitions. So in that way, we could get a very reliable information, okay? And in our future extraction method, there are varieties of methods we have tried, starting from time series analysis, time frequency analysis, frequency domain, nonlinear analysis, and spatial domain. And we also used the topography images to understand the imaging pattern of a different emotion in NC and PD people. After the topo plot, we started plotting the connectivity map. Connectivity map in the sense how the information is traveling from one region of the brain to other region. For example, left hemisphere to right hemisphere, how the information is traveled. Is it unidirectional or bidirectional? Is it stronger or weaker? All this kind of thing could be analyzed when we do the functional connectivity patterns. And finally, of course, we do classification. Because when you develop some system for clinical application, we have to always keep it in mind that you should not simply reflect by number, 98.9, 92.9, 98.2, like that, because the doctors really, they don't want the number. They want visual evidences that could give them more clear and better understanding. So when you want to show a visual representation of your result, this topo plot and connectivity plots are very useful, besides the accuracy. So in that way, we try to combine the analysis with the different kind of outputs. And classifier, of course, we use varieties of machine learning classifier. So one of the major advantage in machine learning classifier is it is very useful for a smaller size data. And only one of the important thing is the hyperparameter tuning would be a challenging one. But however, nowadays we are using a lot of optimization technique. So to select the appropriate hyperparameter for improving the accuracy. And if you look at your deep learning approach, we have varieties of methods we started working on. We recently started working on. So currently we are working on CNN network. We have tried with 1D CNN with only time series information, 2D CNN with the mapping the biological signal information into imaging modality, okay, to trying the network. And 3D CNN, it's like an emotional video stacked all the video samples together to train the network. So this has been completed and it is giving a very good result. And we could also use a smaller size network, the capsule network, CMS network, variational autoencoder. This could be a other avenue in which you can use for neurological disorder diagnosis. Because since the sample is always be limited, it would be very interesting to use a smaller network. Okay. And different kind of learning algorithm also has been proposed by many researchers in recent year that could also be considered. Okay, these are all basically we are trying to use for classification point of view. When you come for connectivity pattern user approaches, we may use the graph theory or graph CNN. Those kind of tools could be very useful for functional connectivity pattern. The one of the biggest problem what we face here is the limited size of data. We don't have a huge data because this kind of research is very limited. The samples are very limited. So that would be one of the reasons. And we need a very high computing platform, or we may have to outsource the work to either Google Colab or Amazon Web Server for our computation. And selection of hyperparameter is very important when you want to develop intelligent system. Okay, intelligent algorithm using deep learning. This could be the another important challenges. Okay, so now we go to the results section. Okay, so so these are all the some of the experimental results I would like to show it to you. Okay, how we identify the emotional disturbances in a PD people with a different kind of system, different approaches. Okay, we started with the rest state EEG signal, and we also started using emotional EEG signal for valence around cell based classification and discrete emotion based classification. And besides, we also use functional connectivity pattern to understand the information flow. Okay, so we have used a conventional machine learning as well as the deep learning approaches to understand the emotional disturbances in or to identify the emotional disturbance in PD people. Besides, I also like to show you some of our work related to autism spectral disorder. Okay, with the small children. Okay. So as you can see here, when you look at a normal and a PD, if you plot a signal of 14 channel signal, obviously we could not able to identify any visual differences. That could be a differences, but that is not major differences. So it is one of the common thing which is usually we are going to face in our real work. So visual inspection doesn't work in the case of EEG signal. Okay, so when you want to develop our system to classify the NC or PD, okay, so we started with the emotional EEG signal. We have extracted some common spatial features using a common spatial filtering, and we classified the emotion using the machine learning algorithm, okay, to NC or PD. And also we have tried with the different epoch length, EEG epoch, in the sense that what could be a minimal size of sample is required for identifying the emotional disturbance. That is one of the important problems, because we are recording a signal for 45 minutes. You cannot give the 45-minute signal to the system to identify the emotional problem. Rather, you should know what is the minimum number of sample or minimum duration is required. By the way, we basically need at least 3-second data of any biological signal to identify emotion. So we started varying from 3 to 6 seconds. So almost we got a very good accuracy for different emotion, okay, which they above the 90%. So it could be one of the sign, okay, but we are mostly preferring to use 6-second sample that could be more reliable, okay, compared to other systems classification. Okay, so by the way, you could easily classify the emotion, for of NC or PD based on emotional EEG signal. And the another one is about customized CNN based NC or PD classification. So we have just developed a customized CNN, 13-layer CNN network, and almost we got around 88.25% of accuracy in terms of distinguishing the NC and PD from your rest state EEG signal. So we use just a rest state EEG signal to classify either normal or PD. So we almost got a very good accuracy and with the good value of sensitivity, that is 84.71%. So this could be one of the interesting work that we have been performed in the 2020. And we also, as I said earlier, we use the topography tools to show or to identify the emotional distribution in a visual perspective. So as you can see, the figure A at the top shows the PD, how the emotions in the PD is varied for a different emotions. When you look at the bottom of the figure B, that is shows the normal control. So compared to a normal control, as you can see, the PD people have a very distributed emotional center. There is no any concentric center as like a normal people. There are distributed centers are there over the entire brain. That could be one of the indicator that they have some kind of emotional disturbances, okay, compared to normal people. And we also try to analyze how the person emotion changes over an entire period of your experiment. Because as you can see, there are 750 seconds. That is our duration of our protocol. That means in 750 seconds, I project all my emotional videos of different emotions. Okay, so when I'm going to map and compare how the person behavior changes between NC and PD, okay, you could easily understand that the red color one shows the normal people and the blue color one shows the PD people. So when you look at your different emotion, this is the A refers the happiness and B refers the sadness and C refers the fear and so on. It is very important to understand that the negative emotions are usually having a very, very low amplitude responses compared to positive emotions. So it could be one of the indicator that the people are highly depressed with certain kind of emotions. So this kind of tool or the representation could be useful to analyze the behavior of the people. Okay. And following on, we have a very recent work, okay, which has been in the IEEE transaction in effective computing. Here we have performed the classification. All kind of classification has been considered here. Okay, valence arousal based classification, dimensional discrete mode classification, 6 classes, and also we classify normal or PD. Everything we combined. Okay, and then we developed a customized 3 CNN network for 1-dimensional, 2-dimensional, and 3-dimensional, and we try to perform the classification. So by the way, we almost got a very good accuracy if we go for a 3D CNN. So when you go for 3D CNN for valence, we almost got an average of 91%. Okay, 91%. For the arousal, we almost got 97%. Okay. However, if you look at your multi-class, we almost got 88% compared to the normal control of 90. So these are all the indicator which is almost confirming that our data which has been collected in the hospitals, okay, which is always have some kind of impairment in the people emotional perception. Okay. And functional connectivity pattern is the last avenue, okay, one of the important way of analyzing the emotional information transfer between the different region. Actually, this works and all we have considered the higher order spectral future, Okay, symmetric index and power spectral symmetry feature and bispectrum feature for analyzing the emotional information transfer. So these are all the line, okay, which usually used to represent the intensity. So whatever if we are analyzing a different pair of combination of emotion, so whatever the pair of combination is giving you a higher accuracy by keeping 70% as a threshold. So we have come here, we have manually plotted this diagram, okay. However, if you look at your more interesting work, which is of automated work, which is we call as Grange's causality, which is one of the very significant tool which has been developed by Anil Sheth in Canada. So for time series prediction. So we have used this time series prediction method to further investigate the functional connectivity pattern. Okay, how the information flow from one region to another region. Is it unidirectional or bidirectional? Is it stronger or weaker? So by the way, we could able to get some kind of mapping, some kind of differences between different emotions in NC and PD. So the red color one is almost shows the NC, and the green color one shows the PD. However, it is very difficult to get any idea from visual perception. Okay. However, the experimental result already confirmed that this proposed approach of Grange's causality method is performing very well, okay, compared to the other method. But again, I want to stress here, these are all based on the future-based analysis. Okay. We are extracting some future, and based on the future, we are trying to investigate it. However, it would be very good if we can use the raw signal directly on any network to perform this kind of analysis. That could be done by graph CNN. That's our ongoing work. Okay, here at our lab. And finally, we are always working on the cloud-based computing platform for developing a remote system. Okay, since our data collected in Malaysia, and still we are collaborating with different researchers from Malaysia and US and UK. So we are all working together to develop a platform based on cloud computing. Okay, here we have our own database. Okay, whatever the sample we have getting from the hospital, that could be, we could collect the data through the cloud, and we can perform the augmentation. And since the system server is already having our code and databases and all the model, it will give you the diagnostic report, and that report has been communicated to the specialist, neurology specialist, and he will suggest the medication to the people, and he closely monitor the improvement of the people. So this could be another avenue in which people can consider to work on cloud computing to develop an intelligent remote healthcare diagnosis systems. Okay. And this is one of the slide, as I mentioned earlier, for autism children. Okay, actually this work has been performed in Chennai, okay, in collaboration with the central government hospital. So we got the ethical approval, and we have collected the EECG signal and the EMG signal from the ASD affected children, autism affected children, and we have acquired the signal, and we try to classify by using a simple classifier. Just the data collection is over, and we perform the classification, and we could easily understand the emotional disturbance. It is not emotional disturbances. We are here, basically, we are trying to use the attention. Okay, how the emotional changes happen, and that affect the children behavior. That's what our main objective in this work. Okay, and yeah, finally we have to discuss about the challenges. When you come to this kind of brain signal or biological signal based any diagnosis system, one of the very important thing we have to keep it in mind is ethical issue. So when you are collecting a data, analyzing a data, or investigating a data, you should have to be very, very properly, you have to manage the ethical procedures. So in terms of data security, data analysis, and data integrity. Everything is to be very, very confidentially kept it, okay, and it should not influence anyone. And the data should not be used to manipulate the behavior of anyone or for the benefit of anyone, okay. And the another one is the computational complexity. So always, since whenever you are going for a huge amount of data, obviously the computational complexity is one of the important challenges. That is in terms of time, in terms of the memory requirement. So we have to try to develop some kind of intelligent system that could be able to deduct the emotion with a fewer number of samples, rather than huge number of data. This could be possible if you are going through by a pattern recognition approach. If you could able to define a specific pattern of emotion, then it could easily minimize. It's a kind of template matching only. But that is the important challenge. That is one of the challenges in this emotion recognition, because the emotional pattern is always be differ for people to people. So as long as when you are gathering a huge amount of data, maybe you could generalize the pattern into a common way of variation. Otherwise, it will be very difficult. Then the handling the real-time artifact and noises. Because when you go to the hospital, there are huge amount of noises and artifacts may be possible. So whatever the system we are developing, that should be more robust to handle the noises and artifacts. And also the non-stationarity of the EEG is also plays a major role. So we could also have to analyze the non-stationarity issue of the EEG when you are developing a online tool or remote diagnosis tool, because that could alter the diagnosis result to anything, right? And there are some possible statistical property could also be considered before you develop any online or offline system for improving the robustness. And the classification performance is also to be likely to decrease if the online system is supposed to work for long period of time. This is more common. So if you develop a platform, you have to be very careful in maintaining the system accuracy irrespective of handling huge amount of data over a period of time. Okay. And there are future scope is also be there for the newcomers or the people working on this field of research. That is optimization algorithm. We could able to develop some kind of naturally inspired optimization algorithm for developing an intelligent system with a limited computational complexity. Okay, and we could also try to implement a blockchain-based method for improving the system performance in terms of data security aspects. And graph theory is one of the important approach for understanding the emotional behavior inside the human brain, okay, human brain network. If you want to understand really how the human brain network works for different emotion in a normal and pathological people, it would be interesting to investigate more on graph theory. That could give a more reliable result. And when you want to develop a universal system, the multi-regional database is highly inevitable. So what we are using a data from Kuwait and Malaysia. However, this is not sufficient. So the demographic factor is also plays a major role. Okay. And finally, a pattern-based approaches could be considered for developing a vital application and also be useful for visual inspections. Okay. And at KCST, people are working on different domains, mainly on effective computing with the clinical diagnosis for PD, stroke, and autism spectrum disorder. And also we are working on other applications such as neuromarketing, neuroeconomics, and e-learning. And besides, we are also working on the medical image processing work related to COVID-19 detection and infection detection, and stroke detection and severity analysis, and diabetic foot ulcer directions. Okay, so this is my Google Scholar profile and Scopus profile. So you people, if anyone is interested at our work, you can go through it. And if you need any help or any suggestion or any input, please don't hesitate to contact me at my email. So I try to reply you as soon as possible, and I give my suggestion based on my experience. Okay. So thank you so much. I hope I took some more time. So thanks a lot. Yeah.
No issues, sir. It was
Thank you, sir.
Yeah.
It was a very interesting session. Thank you.
Okay.
I request Sweta Priya ma'am to please continue.
Okay, ma'am. Thank you, sir. We have a few queries from the participants.
Yes, ma'am. Yes.
So the first question is how to identify when and what kind of pre-processing is sufficient for the application.
Actually, first of all, you need to analyze the raw EEG signal. Basically, you have to investigate the raw EEG signal. And from the investigation, you need to identify what kind of transients occur. Because the artifact is like highly non-stationary, it is the transient behavior. That there is no pattern is there. So the visual inspection could give you more idea to analyze and interpret your raw EEG signal. So always we do analyze the raw signal of all the patient to identify what is the normal ranges of amplitude variation and what instant the artifact occur. Since we have a recorded video, so we try to monitor with the video of movements. And based on that, we develop an algorithm. So what we develop for our method may not be suitable for you. So the clinical visual investigation of your signal will give you more data. Besides, you need to also analyze, you have to also take into the account of your devices. Because what kind of environment in which you work on? Do you have electromagnetic interferences around you? Do you have power line fluctuation? Do you have thermal noise in your data acquisition device? So all these factors has to be considered when you are developing a efficient pre-processing method. Okay. So the pre-processing method can be a selective or manually selective based on the IAR filter or simple spatial filter, or you could use by automated method, which you can do by EEG lab toolbox by using ICA. So, okay, when you perform ICA and fast ICA, the tool itself can isolate the noises. But one of the problem in the ICA and fast ICA is that sometimes your usual information also to be considered as noises. So we have to try different method to validate the appropriate methods which is suitable for you. That's my suggestion. Yeah.
Okay, sir. The next question is, can we use the topo plot and connectivity plot for any kind of medical image processing?
It is not medical image. Actually, I'm not sure about medical image processing. When you talk about a multi-sensor processing, for example, multi-sensor means you need to have sensors at different locations. Okay, because imaging and all, you only get a two-dimensional plot where you don't have marker. But if you look at your EEG, for my example, I have 14 electrodes, right? So 14 electrode is or placed at a different location. If you go to another application, for example, ECG, okay, you may have 12 leads or 12 sensor. So wherever you have multi-sensor in data, it's available, then you can apply this topo plot and functional connectivity plot for any application. So most probably we are using this one in ECG and EEG analysis. That's my my suggestion. Yeah.
Okay, sir. The next question is, what kind of distribution models did you consider for the analysis of EEG?
Distribution, actually, we have considered two kind of model, dimensional model, and also we consider the discrete model. Discrete model is in the case of 6 emotions, how it is clustered. Okay, that because we have a data of 6 emotion, Either we can classify directly to 6 classes by based on discrete model, or we can combine the emotion into a specific valence and arousal to develop dimensional model. So when you are going for dimensional model, one of the problem what we have is the data imbalance. So we need to use some kind of data normalization technique to make the data to be of same size between your dimensional different dimensions, arousal and valence. So we worked on both this model besides the three-dimensional. We didn't consider the dominance.
Okay, sir. Thank you, sir. These are the questions what we have got from the YouTube chat, sir.
Okay, ma'am.
Now I
Thank
would
you so
like
much.
to summarize the points whatever you have taught, sir.
Yeah.
The key points that are covered in this session are a brief introduction about affective computing, and sir has explained about the different types of emotions and two-dimensional and three-dimensional models, and also have specified the applications of affective computing and has focused on healthcare application and has given brief insights into the methodology of affective computing, and he has also given the different types of emotional assessment methods and has explained about unimodal and multimodal effective computing systems as well as biosignal based effective computing. And sir has also given a brief research work about effective computing in healthcare and in remote healthcare monitoring, like different systems of deep apex and empatica systems. And he has also covered the introduction about Parkinson disease and the corresponding approach what we have followed, and also the EEG based effective computing system for Parkinson's disease. And sir has also covered about deep learning methods and has shown the experimental results of the work that he has done in his university. And sir has also explained the cloud-based effective computing systems and the real-time challenges that are faced in effective computing system, and has also given the few scope of effective computing. Thank you, sir. Your presentation was very valuable for us. We have gained a lot of insight into the effective computing approach. Thank you so much, sir.
Yeah, thank you so
And
much for giving me. Yeah, tell me. Please go ahead.
no, sir, you carry on, sir.
I just want to say my sincere thanks for giving me a platform since I could not travel to India for almost 2 years. It will be happy to share my experience. Actually, it is one of the interesting area and we have a lot of challenges. That is the main thing. The second thing is whatever we do in terms of research, so we are always working towards the society. So what we give back, since we could not develop a very good system, due to many factors, but a small effort is also to be noted by the international community. So I wish you all a grand success. So I wish all of you to be safe, and thank you so much again. Take care. Yeah.
Thank you, sir. And on behalf of Stanley College of Engineering, we would like to invite you for the AMSC Conference 2021, which is being conducted on 15th and 16th of September, sir.
Okay.
Please
Sure.
accept our invitation, sir.
Yeah, sure.
And okay, sir. And the letter of appreciation will be shared to your official email ID, sir. We'll be sharing you, sir.
No problem.
Thank
No
you.
problem. Yeah. Congratulations to everyone and do well. And thank you so much. Keep in touch. Yeah.
Thank you, sir.
Thank you, sir.
Thank you very much, sir. And
Thank
please
you.
do join us for the session from like tomorrow. We have the inaugural function. You're cordially invited to that, sir.
Sure, ma'am. Yeah. Thank you so much. Yeah.
And so you can please continue in the session, sir.
Yeah. Can I disconnect? Yeah. Can I disconnect my?
Yes, sir. If you
Okay, sir.
need to leave.
Yeah. Thank you so much. Yeah. Take care.
Thank
you, sir.
I
Now I
request
request.
Shweta, please.
Okay. Now I request N. Kedarnath Sahu sir to give us his concluding remarks.
You are now unmuted. Am I audible?
Yes, sir. Audible, sir.
Yes, sir. Audible, sir. The members of the keynote session committee and participants who have been attending the sessions for last almost 3 days, a very good afternoon to you all. I thank for being given this opportunity to give the concluding remarks of all these keynote sessions over last 3 days. All of us we know that the keynote lectures establish the underlying theme of the main conference. That is the purpose of a keynote session. They are the plenary sessions where several invited talks are organized to form a basis of background concepts. On the eve of the 3 days over September 12 till date, that is today, on the eve of the first international conference on applied mathematics modeling and simulation in engineering AMAC 2021, we had 12 keynote sessions, including the one just concluded. We had 5 keynote sessions on 12th of September, 4 sessions on 13th of September, and 3 sessions today. The keynote session event began with one of the most amazing lecture by Dr. Suravi Bhatia, Professor, Department of Information Systems, College of Computer Sciences and Information Technology, King Faisal University, Saudi Arabia. And she spoke on opinion mining in information retrieval, one of the most important area of engineering and technology. And in her lecture, she said how the opinions always help for better human-computer interactions. And she said that the techniques in the field of knowledge discovery and data mining are very, very significant for today's researchers. And in our presentation, she told some of the research gaps, the procedural steps, approach of opinion mining, and she also stated some of the important applications are in that area, including search engines, quality assurance and recommendation systems, and what are the various major tasks like opinion identification, classifications, and summarization. So it was all about her presentation of her research work in that particular area, and this was followed by the next presentation, the presentation by Dr. Satish K. Pidoju, Associate Professor, Department of Computer Science and Engineering, Indian Institute of Technology, IIT Roorkee. Sir spoke on design and development of models for mobile malware detection, and in his lecture he highlighted various mobile malware, particularly with regard to Android. He spoke about the motive, means, opportunity, e.g. infection vectors, and he discussed about the malware threats, various detection models, especially the 3 popular detection models: static, dynamic, and hybrid. And out of he mentioned about 2 hybrid models, and he illustrated how to combine the supervised KNN algorithm, K-Medoids algorithms as a hybrid model 2 for malware detection. And he shared many of his research outcomes published in many journals and conferences of international repute. And this lecture was followed by another important speaker, Dr. Silas Iyer, Professor in the CAC Department, Raya University, Ahmedabad, Gujarat, India. And he spoke on innovation and research opportunities and challenges in engineering. And he then narrated what are the research opportunities in the present day context and what are the possible challenges as far as the engineering domain is concerned by many researchers. Dr. Sujit Dalal, Associate Professor, SRM University, he spoke on the artificial intelligence of things, and it was a very very marvelous talk when he was talking about this topic, and he discussed the applications of artificial intelligence in camera device to produce smart cameras powered by AI accelerators from Intel, and he highlighted the superpowers of innovation, illustrating the three key emerging technologies: IA, 5G networks, big data technologies, and we talked about the major AIoT, artificial-based IoT segments, taking examples from wearables, smart home, smart city, and smart industry. And as the last session of 12th, Dr. Priya Mutija, Associate Professor, Center for Management Studies, Jain Deemed University, Bangalore, spoke about the global social and technology trends, the future of learning, and she narrated in the present day context. As an educator, as we have to keep always learning and upgrading our skills, and we have to keep equipping with the current knowledge to be a part of this competitive world. She gave a lot of insights how it's possible to achieve as an educator, and he stated that the recent technologies like blockchain technology is a medium to provide support for lifelong learning in reaching their personal and professional learning goals. And she highlighted the MOOC platform, the online platform, and shared the statistics and facts to reach its highest growth. And various other points like how YouTube is becoming one of the most popular learning platform today. And that was the last session of the day one, that is 12th September 2021. Next day, that is yesterday, 13th September 2021, the lecture started with Dr. Bharat Bhushan, eminent speaker, on securing systems using blockchain technology. The assistant professor and computer science and engineering, Sharda University, Greater Noida, Hyderabad, Greater Noida, India, and he insisted on the blockchain, how friendly it is for the data security, blockchain, this transaction process life cycle, and he explained using a learn-friendly graphical representation of Bitcoin transaction. And he discussed the various core components of blockchain and how it is tamper-proof, and how can you use for cryptography, computation of a hash function, and how it eliminates the need of third party. So it was a really very, very fascinating topic, and he gave certainly a very outstanding lecture, Dr. Bharat Bhushan. And his lecture was followed by Professor Rashid Mohammed, the Professor of Big Data Systems and the Director of Research, Training and Consultancy, HPC Center, King Abdulaziz University, Jeddah, Saudi Arabia. And Sir spoke on big data, HPC, artificial intelligence, IoT, cloud, fog, and edge. They are the core ingredients for bringing innovation for smart societies. And then Professor in the afternoon session yesterday, that is 13th September, Dr. Tanya Stanko, Partners Samsonova and Partners Consultancy from Russia, delivered a very generic topic which applies to across the domains. How do women feel in IT? And she gave a very very clear distinction, of the present day circumstance, and gave a very clear comparison of the presence and the efficiency and efficacy of women and men in various sectors in the industries. And then this was followed by Dr. Preeti Srinivas, Professor PG, Department of Computer Science, Sardar Patel University, Gujarat, India. And Madam spoke on applications of artificial intelligence and machine learning post COVID-19, and she narrated so many aspects of the usage of this so-called artificial intelligence and machine learning in various remarkable areas of research. And her lecture also was very very impressive. And then Professor Selfie Cadre started this morning, 14th September. The first lecture was Professor Cadre. He spoke on some new results on the product and ratio of random variables with applications. And this is something, the probability density functions, which most of the time we use for various communication analysis, statistical analysis in the field of communications, and the probability of occurrence of different possible outcomes in any experimental analysis can be studied only by using a suitable probability density function. Professor Kadri introduced various key probability density functions of products and ratios of random variables, and he introduced the very, the very prominent distribution functions like Maxwell distribution function and Rice distribution function, and he also illustrated the distributions like Weibull and Langley distributions as well as the Maxwell-Boltzmann distribution. And he mentioned about the Pareto, Rayleigh, and exponential distributions and how they are relevant to the statistical studies. And Sir explained the Monte Carlo distribution with regard to the independent Maxwell variables. And he shared most of his research outcomes on the pioneering area of random variable analysis, and this will certainly benefit to the budding researchers pursuing their research work in the School of Statistics and Probability especially. And this lectures this was followed by another eminent speaker, Dr. Saravanan, head of the department and assistant professor, senior grade, Department of Computer Science and Engineering, Anna University, Tamil Nadu, and Sir spoke on secure, sustainable smart cities and IoT, and how a particular, you have now everyone around the globe are aiming for sustainable smart cities. It should be smart cities. There are various attributes for a city to become a smart city, and how the attributes can be sustainable, and therefore the smart city also can become a sustainable smart city. And what is the use, and how to use the artificial intelligence, machine learning, IoT to make the smart city as far as possible sustainable. So that was the focus of Professor Sarunan in his lecture. And then the last session was just ended by Dr. M. Murugapan, the Kuwait College of Science and Technology, Kuwait, and he spoke on effective computing systems for neurological disorder diagnosis, and how the technology, they're all, there for various healthcare systems, for emotional modeling, development of emotional system, and a very good summary was presented recently. And this is overall the summary of all the 12 sessions, and that's what we feel that we have already received a tremendous exposure to some dozen of lectures, extraordinary lectures from great personalities, professors, and researchers across the globe. All lectures and deliberations were related to the research work on various avenues of communication, computer science, and information technology. The deliberations were amazing, informative, and no doubt they were eye-opening for participants across various professional identities, be it students, faculty, or research scholars already pursuing research or aspiring to pursue research. And I hope the participants, I hope that you certainly have big takeaways from all the sessions, and we are grateful to all the eminent speakers for making it convenient to deliver their respective keynote sessions with abundant patience and a great deal of effort. So, with this consolidated background, I believe the participants will have a consolidated, will have a very, or might have learned various concepts from various plenary talks, and I hope will be comfortable to participate in the keynote sessions and the paper presentations of the main conference beginning tomorrow, that is 15th September 2021. And, congratulations to all of you, and all the very best. And thank you for giving me this opportunity. Over to Madam Shweta Priya.
Thank you, Dr. Sahu.
Thank you, Dr. Sahu.
And I
Thank you, madam.
cordially invite all the participants, delegates, and the keynote speakers, and Dr. Murugappan sir, to the inaugural function to be held tomorrow, the 15th of September at 9:30 a.m. We request your gracious presence, sir. Participants, we shall meet you tomorrow again at 9:30. Please stay tuned. Thank you so much for the support and the patient listening. And I'm sure all of you have gathered a lot of knowledge during these 3 days. And I hope to have you participate in the next 2 days and make the event a grand success. Thank you. And yes, sir.
Thank you so much, Ma. Thank you so much,
Thank,
and take care. Yeah. Bye-bye.
thank you, sir. Thank you. You too. Bye-bye, sir.
Bye-bye.
Thank you. And we conclude this for the day. And please join us tomorrow for the inaugural. Thank you.